All right, so this is just a brief overview. It's a little bit more about what ARM is and why we're here and all, and then we'll go a little bit into this particular study. I'm doing this with also who we didn't introduce is Derry Dexheimer, who manages the ARM's tethered balloon system. She is just called me and said that their internet's gone out where she is at, and she can't participate, but she emailed me some slides, which I will try and go through on her behalf here. So first of all, ARM, the atmospheric radiation measurement user facility is a DOE, United States. I'm going to try and not speaking too many acronyms, is a U.S. Department of Energy asset, and with a broad mission of trying to improve the representation of clouds, precipitations, aerosols, and how they interact in climate models. So this is done primarily through making lots and lots of detailed observations. We have a network of sites, of what we call observatories, that are around the world. Some of them are in fixed locations, making long-term measurements. Some, like this observatory going to CoURAGE, move around all over the place to try and cover the globe. ARM's been at this for a long time, over 30 years now of doing this type of work to support model improvement. We also have some aerial platforms, a piloted and some UAV program. Our piloted program is still, we bought a new aircraft not so long ago and are still fixing that up, so that's not going to be available for CoURAGE, unfortunately, but we do have some traction on maybe flying our drone around in the Aberdeen Proving Grounds just north of there, so that's interesting. ARM also has an extensive data management system to really try hard to get data and usable data products out into your hands, you scientists, who we hope will help us meet our mission of improving models. ARM also runs its own model. We have a large eddy simulation that we do. And finally, we also provide a lot of support for people to come and work at these facilities to leverage the science that we can get out of these. So we want you as scientists to participate hands-on, to take advantage of the infrastructure that we're bringing out and the measurements that we'll have there with your own instruments. And we work hard to try and support that. So this map here shows all the places where ARM has been or is currently making measurements here. So it really does cover a huge part of the globe, all 7 continents that the measurements have been collected from, representing a really diverse set of climate regimes. Where we go is really up to you folks, the scientists here, who drive the location by presenting what the scientific need is to ARM, and we try hard to fulfill those measurement needs. So that's a big part of what we do. The mobile facility, whoops, I think this is on a timer here. The mobile facility here, as I mentioned, we have ground-based observatories. Three of these are mobile and move around the planet. We call those ARM mobile facilities, AMF. I'll probably use that a lot here. The AMF-1, the first mobile facility ARM had, is what's coming into CoURAGE, and of course it's awarded through a competitive proposal process, which really helps us make sure that we're meeting the demands of the user community. Just briefly, some of the instruments that are a standard part of what the ARM observatories bring. A group of instruments focus on meteorology, atmospheric state, radiation. We, of course, launch radiosondes. We have a set of broadband radiometers and some spectrally resolved radiometers, an AIRI, which is a spectrometer that gives us measures the infrared emission of the atmosphere and lets us do interesting things with it. Wind profiles and boundary layer structure with Doppler lidars, eddy flux, energy balance, microwave radiometers for liquid and water path and water vapor path. We're very interested in clouds and precipitation, so a comprehensive suite of instruments for doing that. A number of LiDARs, a Ka band cloud radar, and a full suite of precipitation instruments to capture precipitation very well. Finally, we're focused on aerosols and trace gases, so we have a very comprehensive suite of aerosol and atmospheric chemistry instruments that we'll also be bringing and supporting for this. So a lot of instruments, state-of-the-art measurements, and a lot of effort goes into making sure that ARM is producing as high quality data as possible for the whole campaign. So that's really what we want to do. ARM also really puts a lot of effort into making sure that data gets out to you as scientists as quickly and as easily as possible. So ARM's data discovery is a wonderful interface for being able to find data that you're looking for. ARM at any given time has over 400 instruments that we're actively operating in the field. We have over 10,000 data streams available. And so a lot of effort goes into making sure that these data are available to you. So I encourage you to go dig around and look at this, because this will be the go-to place to get data from CoURAGE here. And there's just a few graphics here showing some of these things in data discovery. Additionally, a lot of those data streams have further downstream products made from them, our value-added products. I've listed a set of what we call the baseline products that most of these VAPs will be produced as a part of this study. And there's a link down here. I'll upload these slides so you can read about them. But these are really, really useful products that combine a number of the different data streams to try and make really useful sets of products for people to be able to start doing science right out of the gate with a lot of these. So CoURAGE, just focus on the campaign a little bit here. So of course the G in CoURAGE is a gradient, and you see on this map here, ARM's participation in this is largely through putting instruments and making observations at 3 different sites that represent the gradient that this experiment is trying to capture here. Starting in the top left, we have this rural background site where we'll do our aerosol measurements to try and capture the air masses before they enter into the urban area. This urban site here, it's going to be at the Lake Clifton School. That's going to be the main thrust of ARM's measurements. The bulk of our facility, our observatory will go here. And finally, out in the Chesapeake Bay, there will be a 3rd site for capturing sort of this bay dynamic that we're trying to study. So briefly, the campaign starts December the 1st officially. So that's whenever ARM will be making measurements. Data will be flowing to the archive then, and all to achieve that, we'll actually be on the ground there in October and November, getting things installed and everything working. It's a pretty big production that will be there. So we'll be visiting there in earnest towards the end of the summer. I'll also mention, put over here my bullet points, that as a part of this main site, we're going to have 2 eddy covariance systems that will be located on building tops around Baltimore or around the downtown area. They won't necessarily be located at the school. And additionally, ARM has an instrument that we call stereo cameras that lets us do 3D reconstructions of clouds, and we'll be setting those up at an appropriate location, which means it needs to be far enough away from the main site to observe clouds over the main site. So lots of sites there and lots of activities with it. Just to go into these sites briefly, this first location I'm showing is the main site right in the city of Baltimore on recently acquired Morgan State campus. It used to be the Lake Clifton High School. There's this nice big field that you can see on the southwest side of the school, and there's just a photograph here of where we're going to put all of the instruments. Perfect place for doing this kind of work. Nice big flat open area with a great view of the horizon. So we're looking forward to working in this location. We'll note though that ARM's aerosol observing system, the AOS, is not going to be located here. We're moving that into the upstate rural area. Aerosol measurements will mostly be covered by other assets associated with BSEC for this. We will have aerosol particle size and concentration from a POPs, but that'll be it. So we'll move to upstate Maryland and Frederick County, and this is rural farmland where we've found a very nice location for capturing this background air mass. This is where the bulk of ARM's aerosol measurements will go. So we'll have a site located at this farm here for aerosols, along with some other atmospheric properties. We'll also be launching radiosondes from this area. I apologize, I meant to say that we'll launch routine radiosondes from the main site at Lake Clifton, as well as during the intensive periods at this rural site. Our final site is at the very tip of Kent Island, here in the middle of the Chesapeake Bay. And this originally was going to be our tethered balloon site as well, where we'd be flying the balloon. Unfortunately, we have met with the force of the FAA, who wouldn't give us permission to fly it here. Unfortunately, it's too close to Washington, D.C. airspace. So we found a different location now for that. We'll talk about that in a second. But anyways, you can see in the picture here, this location really is at the very tip of Kent Island, and lets us get instruments right out to be influenced by the Chesapeake Bay. All right, this is where I would hand this over to Derry Dexheimer, but instead I'm going to share a different screen and this. See how we can do on this. So her slides. The Adobe Acrobat. Where did you go? Oh, here we go. All right, are you seeing those slides, or are you seeing my whole screen?
We have your whole screen.
Ooh, let's try that one more time.
There you go.
All right, that's better. Thank you. All right, so the ARM tethered balloon system at CoURAGE. So Sandia National Laboratory is the national lab that manages the ARM's tethered balloon system. I should have said earlier that the ARM user facility isn't at just one national laboratory or at one entity. It's spread across lots of different national labs and some universities as well. So we're a big, bulky, spread out organization who works surprisingly efficiently together, I must say, on that. So this is Sandia National Lab. So just an update on what the plan is for the tethered balloons. I mentioned Kent Island wouldn't work, or Kent Point wouldn't work for some compliance issues. So we've located a different area. This, I don't think I have a more zoomed out photo than this here, but if you look over just across on the east side of the Chesapeake Bay, you can see the two proposed sites. The one at the bottom, the more southern one that says the, what is that? The Andelot Farms is where we're currently planning to fly the tether balloon for CoURAGE. And this is contingent on national laboratories negotiating real estate transactions with a local landowner. So we think that should work out. There's also a backup site a little bit to the north at a county park here that we're also looking into just in case this farm's site doesn't work out. So anyways, this is the current plan. I think it meets the requirements. We've sort of circulated this with a lot of the science team and think we have a good location for flying this. And this is still pending. However, we did get preliminary flight approvals from the FAA for these, so we don't expect to run into the same compliance problems as we did before. And here's just some photos of what the layout is. You can see this top picture shows an open area that'll be appropriate for flying the balloon. This bottom photo is some of the areas that we'll probably look to operate in and put in some infrastructure and all. But this all looks very doable. We just have to get the paperwork done on this. Let's see. And lastly, here's what the schedule is looking like. So we're looking at right now two different flight periods: a winter flight, maybe potentially at the end of this calendar year or early next calendar year, which would be a 2-week deployment in this area. And then again, about 6 months later, we'd have a summertime flight associated with an IOP. I've listed some of the instruments there. Derry's listed some of the instruments that will likely fly on the tethered balloon. And this graphic on the right, it's a cool graphic. I just have the PDF that usually moves and does all kinds of stuff in PowerPoint, so we'll have to show that some other time. But it basically, the idea with the tethered balloon is it can hoist instruments from the surface up to about 1.5 kilometers above the surface and do a series of profiles, or it can just go up to a certain elevation and hang out for a while and make measurements there, what we call loitering. So we'll talk a little bit more about that as the campaign gets closer to. We'll have a targeted call about this. All right, I've got one more little bit here to bring it home. Just a little stop sharing thing. There we go. All right. Yeah, lastly, I'll just make an appeal to you all here to use ARM's website. There's some great information on this website here. I encourage you all, I put the link up at the top here. It's www.arm.gov. There are fantastic resources on this site. One of the first things you should do is register. Down at the bottom of all the web pages, you'll see this create an account. Once you do that, it's really painless. I promise we won't send you junk mail or solicitations or anything, but it's a really good way to get access to data, to quick looks from this study here. You'll be able to see data quality plots. Corey and the outreach ARM communications team are often putting updates and news articles on this website. So there's a fantastic amount of information that really plugs you into what's happening with this here. So please, I encourage you to, as soon as you can, register for that and start looking at this. One other thing we'll mention is at the bottom of all these web pages, there is an Ask Us button here under Help, and that is extremely effective. You can use that for everything from, hey, I see a problem in the data that I'd like somebody to look at, to could somebody help me figure out how to, how to get permission to visit the site or that. So you can get a lot of help from just using the Ask Us button there. You'll get access to things. One of the things that we produce is a field campaign notebook here. So this is really meant to be kind of a clearinghouse for a lot of the useful things that ARM can provide, a lot of the tools that ARM can provide to you as the scientists working on this. It's a way to get to quick looks for all of ARM's data streams. So you can basically look at instrument data real time from this. We try really hard to get data out of the site and into our quick looks as quickly as possible on this. There's also a map that'll have the regional radars, the National Weather Service, and any other radar that we can find showing precipitation and satellite overlays. There's different satellite products that you can view on this. So it's a really neat tool. We'll be reaching out actually because this is also configurable and we want to make this as useful for the PI team as possible. So we'll spend a little bit of time with Ken and his team to try and make this customized for CoURAGE. I mentioned earlier too that we encourage people to come and participate and bring instruments and use our sites. We do have a process for that. If you want to bring an instrument to one of our ARM sites, which we hope that you do, we'll have a small proposal process to go through. It's on the website. There's a propose a campaign button on there. It's not hard to find on the left. You can see it's a very simple form. You don't have to write a 28-page pre-proposal. It's just a few sentences describing what you're doing and what you need and how ARM can support it. That lets us evaluate what this is. So we'll be asking everyone, and several of you have already done this, but if you're planning to participate doing work on one of those 3 ARM-supported sites to do a campaign. And yeah, finally, I'll just say, we're here. Our goal is to help you succeed. We want this to be as impactful, as a useful campaign, get as much science out of this as possible. And, my job and ARM's role in this is really invested in helping you succeed in doing science. So we're here to help. Please reach out. Please ask questions. You can use the Ask Us to reach out to. So it's really looking forward to this and hope we can help you meet your scientific goals on this. So I guess with that, if we have time, I probably ran a little long here, but I'd love to take any questions if anybody has any.
Thank you, Heath. You did run long, but you're bringing all the toys to the show, so you get time. We do have a question, at least one in the room. If anybody has something online, either raise your hand or blurt out. Ben Nault.
Hey, Heath, quick question about the NOx measurements at the rural site, because the last CoURAGE meeting we had, it sounded like there was just always going to be a NOx box, but your slide is showing IOP only. So I was wanting where that stands so that we can plan how to supplement if necessary.
So this is active. This is an active discussion right now, Ben. And actually, I'll kick this over to Adam Heisen real quick, who can give you a little more information. We basically have been evaluating an instrument to deploy there, and I think ARM is determining that this instrument isn't suitable for making long-term measurements. So we're a bit going back to the drawing board. But Adam, can you maybe tell us?
Yeah. So we were evaluating a Miro gas analyzer system that would do 10 gases, including NOx and a bunch of others. It turns out that is not going to be feasible for ARM operations. We're not getting really the results we want out of it. So we are pivoting and looking at other options, as Heath noted. If there is the potential for a PI to bring a NOx system, I think that's great. We can work on that. So if you're interested, please let us know. But otherwise, we will be looking at Plan B options. So,
Adam, we'll talk offline because we have some questions about the Miro because we're looking at getting one of those as well. So,
okay, I'll get you in touch with our Brookhaven folks. They've done a lot of good analysis, and yeah.
Right. Thank you.
Great. Other questions for Heath or Adam or other folks from ARM?
Heath, I had a question about where the tethered balloon will be at. Will there be any other supporting surface measurements to go along with the tethered balloon?
Yeah, that's a good question. Good to see you, Paul. I'm glad you're working on this here. So we'll definitely have some kind of a boundary layer measurement there, either a ceilometer or Doppler LiDAR, and some ground surface meteorology there.
Okay,
Okay, thanks.
lovely. Ellie,
So, Ken, I guess that's a question for everyone. You're aware of the Cub Hill Tower, right?
aware of,
Cub Hill Tower. So the Cub Hill Tower is a 40-meter tower in suburban Baltimore, part of the LTER, that's been collecting anti-covariance fluxes for 20 years now, maybe, over like a mixture urban suburban, not far from Baltimore.
we're aware of it. I don't think it's running anymore.
Okay, so but you're not planning to deploy anything there?
No. No, we will get more. We do have flux measurements planned for the
Okay.
city. But Cub Hill is not running at this point, and we are not gonna go back there. Correct. Cub Hill, yes. Yeah, it was with the part of the Baltimore ecosystem study, I think, maybe.
Park Service ran for years,
Forest Service, I think.
but I don't know how long it's been shut down.
Yeah, been shut down for a bit. I think the data, I don't know if the data are publicly available. I don't know if they ever were posted.
Data are not easily available.
No, the data is a pain.
We have flux tower plans. Not that site. Okay. Thanks very much, Heath.
Thank you.
Thank you for getting up super early. So rest of the day, my general plan is to start with background about the project itself and the measurements. And this was the beginning, the folks who are actually bringing the measurements to town. And then hear about other observational plans that people are bringing to the region at about the same time. Move on then to analysis plans. And then in the afternoon, talk more about what we need to do new going forward. So that's the rough agenda layout. I also wanted just to jump from what Heath was saying. Holy cow, they've got a lot of resources and good tools and things that are more complicated than we know. And it's good to try to learn what ARM can provide and do. And so at some of the monthly meetings that we've been having, I'm going to get the ARM data system experts and value-added product experts to show up and talk to us about what tools they have so that we will go into the project more able. So especially folks who plan to work with the data, these would be good meetings to get to. And I don't know if we can do that as early as next Thursday, which would be our next, that's the next one on the calendar. I'll check with Heath and company about that. So keep an eye out for that. The other thing we're going to have to do, and there was an allusion to the measurements in Baltimore for BSEC that will be part of CoURAGE in a way, is we got to work on getting the data systems merged. So that's another topic that we'll be working on, but try not to do it at this meeting. Use this more for science planning, but in some of those follow-up meetings, you really have to get the data sets talking to each other. Okay, great. So next up was me giving a quick overview of the project. And let me see if I can. No, I'm already sharing everything. That's not what I need to do. Let me find the pile-ups. Is that the right thing?
That's like the right thing.
Oh, that's the,
Courage overview.
yeah, hang on. I don't want to get it out of here. I'm just being picky. I don't think that's evil. Well, sorry, I'm not used to. There, this is where I want to go. Downloaded everything here. So Heath covered some of this, so I will not be redundant as much as possible. But this is, and I apologize, I don't have a science plan published yet, darn it. This is what was largely in the proposal. The proposal minus all the CVs and stuff is in the meeting folder. I also want to note there's in the meeting folder, there is a folder for notes, and there's a document up there for notes, and I put the notes chat link in the Zoom chat if you want to help take notes during the meeting. that we can all share. Take notes. It'll be recorded, but who wants to sit through a 5-hour recording? So please help us take notes if you want in that document. But anyway, this is basically what will be in the science plan that came out of the proposal. This was motivated by the BSEC project. I'm not going to spend much time talking about it. You probably know something about it, but it's one of the urban integrated field laboratories. Ben Zaitchik, who can't be with us at this point, he's away with family, is the lead of that project, but it's got a bunch of institutions and a bunch of measurements happening in Baltimore. It was the basis for putting in the CoURAGE proposal. I'm back. And so we want to understand the city, but if we want to understand the city, one of the arguments we made is we need to understand the neighboring environment as well, not just the city. And so that was, and we want to measure more in the city than we can with just what we have for BSEC. So that was the basic argument behind CoURAGE. This is no longer complete. I don't know what we're going to do, keep up an investigator list because people keep showing up, but that's good. So this is a good problem to have. But at some point, this was a list of people who were involved in putting the project together. I put it up here mostly to show there's a bunch of institutions who are interested. And the colors are the kind of the disciplinary foci of the people. And red is surface atmosphere interaction. So you can see there's a lot of red up there. And there's a fair amount of blue, which is atmospheric composition. There's quite a bit less purple, clouds and radiation, and precip, which is yellow. Nevertheless, that's the folks who came to the party initially. And ARM does a lot of clouds, radiation, and precip relevant work. So bring your colleagues would be one message there. And again, two foci, beef up what we're measuring in Baltimore. The main facility will be in Baltimore. And we'll add a lot, especially about clouds, radiation, precip that we don't measure as part of BSEC in the city. Plus, we'll have those ancillary sites that Heath talked about. Plus, we've got a partner site, DC, in the DC Baltimore area. I'm in the DC area in Beltsville, Maryland, which we'll hear more about, I think. Whoops. Oh, it's still there. The screen disappeared. Okay, it came back. Good. We put this in the proposal. This is kind of classic ARM interactive system. You know, surface interacts with the fluxes, interacts with the boundary layer, alters the clouds, the pollutants alter the clouds. This all changes the precip, changes the radiation, alters the surface. Yeah. All the red stuff is the interactive process. All the black stuff are the different tools to measure these different pieces. And we try to measure all of this in Baltimore and parts of this at those 3 boundary facilities. And again, 4 focus areas, boundary layer properties, composition, clouds and radiation, precip. But a big focus also is on how much does the upwind alter what's in Baltimore versus what does the Baltimore environment itself dictate about this urban atmospheric environment of the city. So that's why we have a lot of these multi-site layouts. This is a picture of the ARM mobile facility, but the same Baltimore. You've seen it's Heath's background too, and he showed you a picture as well. And Heath showed you this picture as well, but I've also added here a circle around the Beltsville site, which won't have any ARM mobile facility measurements, but has a lot of the same sorts of instrumentation. And we hope will serve as the DC background data for Baltimore. When the wind comes from DC, hopefully the measurements in DC and Beltsville will characterize that air mass as opposed to the Bay or rural Maryland. Some of the BSEC background, this is largely Darren's work and colleagues. This is the surface weather network that's being deployed and it's still growing around the city of Baltimore to get, 2-meter temperature relative humidity wind. What do people live in? Measurements. Network spread out across the city. And this has existed in the past. It preceded BSEC, the Search Air Quality Network, a series of low-cost air chemistry measurements spread out around the city. We're our colleagues will tell us more about the indoor-outdoor high-quality super site that's being planned. This will be the aerosol measurements and chemistry measurements in the city that complement the rural measurements being made by ARM. So those two will give us background urban. This is another map zoomed in on the city. Heath didn't show you this one, I don't think, if I remember. The Doppler LiDAR for BSEC. BSEC is red. ARM is, oh, I got the colors backwards. I'm sorry. Colors are all messed up. My bad. All right, I'll just tell you. This is a BSEC Doppler LiDAR that's currently down. Optical amplifier broke about 3 weeks ago. We're getting a loaner in and then sending it back for repairs. We should have it back up at the end of this. We should have something in place at the end of this month. And then the repaired system, hopefully in July. Bummer. But we have a Doppler LiDAR running here at the roof at Morgan State, thanks to Shawen and our colleagues for helping us get that going. We will be putting in 2 flux towers, Ellie. One will be in a residential neighborhood just south of Clifton Park, and another will be in a residential neighborhood to the northwest of downtown. These are on communications towers. We didn't not build any towers in the city. Instrumenting communications towers. And then there is currently a flux tower running in the grass at Clifton Park, thanks to Ben's work. And Ben is also putting up the flux towers as well. So flux towers, find Ben. And then as Heath noted, we'll probably have 2 ARM towers, and these are approximate locations, but they might not be too far off the reality. Building tops, more urban downtown rather than residential. You wouldn't call the sites we're setting up suburban, but they're residential, not commercial or offices. Anna.
What trace gases are the flux towers going to measure in addition to all of like CO2, methane? Which of these?
CO2, methane, those.
All of them will
No.
have that?
No,
So
the
which ones?
CO2, methane, except for Clifton Park, is just CO2.
But the new ARM ones will have methane?
No, sorry. Yeah,
That's what
all
I'm
right.
getting at, like that.
These,
always flux
these,
tower, yeah.
these 3 will be CO2
CO2,
water
CO2.
energy.
Okay,
The Howard Park and Broadway East will add
we'll
methane,
have both. Okay,
will
thank you.
add methane.
Just for your information, there's a flux tower operated by USDA. No, so
Yes.
CO2
Yes,
and doesn't do methane.
yeah, we'll have, there'll be flux towers at all the ancillary sites.
CO2.
Yes. Yeah, all right, you saw this one already?
And there's another question.
Another question? Yes, Maurice.
2 quick questions.
Yeah.
What kind of Doppler LiDAR is that?
Halo?
Okay, it's the Halo is catalog.
Yeah.
And then the star that's north of 83, do you know like exactly what building that is?
I know we're talking to Micah.
Oh,
Mar-
okay.
Maryland Institute College of Architecture, Arts, yeah, talking to Micah.
I asked because I didn't place it.
Gotcha. All right, yeah, Micah rooftop, probably.
I
Ben.
can, comment quickly. I'm visiting Micah next week. They seem like it's a go. We just want to have a look at it. And we're also looking at the Peabody campus for a JHU here, and I'm checking some options out there next week as well. So
That was my guess for this star.
Mike is actually interested in that. Some of their students, it's hard. They do take classes of like climate change, how to do, understand. So,
Yeah, it'd be fun if they want to learn more about it. That'd be cool.
Hey Heath, real quick on that point, because I've been traveling, I'm behind on emails. I saw one from you. Do you have the contact you needed at Peabody, or are you still waiting on us for that?
yeah, I could use a contact for
Okay,
Peabody.
sorry. Yeah. All right, I saw the email but didn't respond. I'll get that to you.
Yeah, cool. Thank you. And if not, I'm gonna at least identify what I think will be good buildings and have some specifics to work with too after Wednesday. So sounds good.
Great,
Thanks.
thank you. I'll get that to you this evening. Yep.
Good. Ben,
Right, so the ARM, urban flux towers, are those gonna be short stature on flat roofs?
Probably yes,
Yes.
probably yes. Yep. And I also did not put on here, there are gonna be a couple of stereo cameras to look at cloud development, and I think they will be to the west. But looking towards the main facility, which will be here at Clifton Park, to take pictures, views of the stereo pictures of the cloud development over the city. All right, you've seen this. But I added the Beltsville site, and I also note the NOAA NIST Doppler LiDAR that's in downtown DC is an addition. And there's a whole bunch of radar resources on here that are operational. And I also note, holy cow, there's the Horn Point, Beltsville, and Piney Run radar wind profilers from the Maryland Department of the Environment. There are going to be more wind profiling measurements in this area than you could shake a stick at. There's Doppler LiDAR at every one of these locations, and I'm missing a couple still. It's crazy. This is going to be an incredible wind profiling boundary layer measurement environment. Wow. That's part of why I think we got to get these data sets synthesized, because I don't want like every grad student say, oh, how do I put these 7 different wind profiles together and have to reinvent it every time? We should make this easier. Plus the aerosol data and that kind of stuff. Yeah, and the boundary layer height retrieval. So it's not all have to drive boundary layer height independently every time we get one of these data sets. Maurice.
On that note, I love what you're saying. It's great.
Yes.
Is there already a team together for that?
No, not yet. Not to do the data, but we're close to trying to say, hey, let's get together and talk about that issue. We need to. Excellent. That would make Heath happy. All right, and so this now gets into more of the weeds. This is an instrument list. This is in the proposal. I don't really want to stare at these for long today. But if you're curious, what we did, and thanks to Pete DiCarlo for making this nice table, which I have to now remake, but I don't have your software. So if you want to help me. Yeah, right. Okay. I don't have the Excel. I don't know if I have the Excel file, but if I do, I'll try to use it.
I'll share.
All right, cool. Red is ARM, blue is BSEC. And these are the 4 nodes: rural, Baltimore, Beltsville, Bay. And category, boundary layer properties. So you can see that almost all the sites have a pretty good selection of boundary layer measurements. Hatched is IOP only, intensive observation period only. So there's boundary layer properties, and you can see the types of measurements: Doppler LiDAR, eddy covariance at all the sites. Bay, we want to have it out over the water, for example, to measure the fluxes coming off of the water. Radar wind profiler, SONS, SODAR, MET stations, ARI, infrared atmospheric profiling, only one of those. Pardon?
There may still be 4 IOPs, maybe 3.
There may still be 4 IOPs, or there may be 3.
Presentation, the decision on that is coming.
Understood. At the moment, we have 2 2-week IOPs. Pete's trying to make that grow.
Don't cross it out yet.
Pardon?
Don't cross it out yet.
Well, yeah, all right. We initially proposed 4 4-week IOPs, and ARM said, no, that's too much. Can't do that. How about 2 2-week IOPs? So now we're negotiating through proposal processes. This is the atmospheric composition list. And I don't even know what half of these things are very well. But there is quite a long list of atmospheric composition measurements that ARM will set up at the rural site. These are Pete and Ben's measurements largely for BSEC. And then Beltsville has quite a suite of measurements as well. And then the Bay will have measurements during IOPs, largely due to folks' mobile labs heading out there. And we got 2 mobile labs, at least in the room. Zhejiang and Ben and Pete both have mobile labs that may go out to visit some of these locations. Do we have 3 also? Shinrong, yeah. We've got 3 mobile labs in the room for atmospheric composition, plus at least an airplane or 2. So there's going to be a lot of additional measurements. That's what we're going to hear more about.
the mobile measurements are the plan for the IOPs only?
To be discussed.
Yeah, TBD, that, we gotta talk about that. Yeah. I think the IOPs are an obvious time. More than that, maybe.
There will be more than that, but you can't.
We're not organized as far as the complete more than that yet. Anna,
You comment on the rural site GHG measurements or the, because I know there's the flux tower there, but
yes,
it looks like they're also gonna have trace gas, CO, methane, CO2.
Yeah.
Do you know anything about that? Like the height or?
I don't think the height will be tall. I think it will be surface based. Yeah, surface based.
But concentration measurements that will be calibrated that we could potentially use?
Yes. Yeah, I'm pretty sure they're using the Picaro for the CO2, CH4. CO, I'm not certain. But we can get all that info out of the ARM, as Pete said, man, that ARM website, you can drill down to all the details and find the expert about the instrument, call them up and say, hey, what is this? You know, how does this work? What can I do with this?
On those websites he had posted.
Yeah.
On the presentation.
They have really nice discussion about each.
Yeah, there's documentation about all the instruments. There's experts to contact to learn what they do and how they operate them. It's deep. And radiation. Infrared, sky radiation, photometers, shadow band radiometers. Lots in Baltimore at the core site. A little bit at the other site. Some already exists in Beltsville, thanks to our Beltsville colleagues at MDE, Howard, University of Maryland, probably places, institutions I'm missing who collaborate to get that instrument site together. That is one of my worries, is that site has lots of different people bringing things, and we have to work on getting that data set accessible to the team as well. And clouds and precip, most of the clouds and precip measurements in Baltimore, because that's the city we're trying to study. And we don't have enough to spread this around to all the different locations. But upwards looking cloud radar, Baltimore. Salometers across the set. There will be microwave radiometers at all the sites. So that's pretty good. There's already a micropulse lidar also at Beltsville. Precip, mostly Baltimore. Laser distrometers across all the sites. Is the one that's in Beltsville actually at Goddard? Yeah. I'm not sure.
Howard University campus has some on campus. It greened up Goddard.
You probably know more than I do. I just took information, putting the proposal together and put colored in boxes.
There actually could be one of the older versions that we had.
Okay.
But the two new ones that the judge.
Okay. All right. And we had a pile of research questions we asked. I won't go over these in detail, but we had surface atmosphere questions, atmospheric composition questions, clouds and radiation questions, and precip questions in the proposal. And this is an ARM mobile facility proposal, so it doesn't come with the funding to do these questions. So we had all you folks, or some of the folks who aren't in the room, say, we'll help answer these questions with projects that we already have or with new proposals that we're going to write. And so that's part of what we have to plan this afternoon. This is in the proposal document. It's in the slides. If you like these, want to review these things, it's out there. And I'm not going to go through this table, but this is the basic, as Heath noted, value added products. And there's a host of these that ARM creates. And again, lots of documentation about what all these are and what they do. And thanks to Mike Jensen, who can't be with us for this meeting, unfortunately, who helped point me to this table. But there's a ton of these value added products where meteorological properties are derived from all these, raw measurements for our use. And then we added a few extra requests, mostly based on Mike Jensen's guidance. He said, you should ask for these too. For example, the geostationary cloud satellite products. Cool. All right, And I will note one last interesting note. We have, I love this term, we have a ARM mobile facility translator. I think that's a great word because this is so full of acronyms and complicated stuff. You need a translator to help understand what it is. We have a dedicated translator for the deployment. Demao Zhang, we want to get him at one of these meetings and help us out. Questions?
Yeah,
Yeah.
I guess this should previous one, but just wondering, the raw data, will that be accessible on our site as well, and not just process data, but actually develop?
I'm sure it's some form, you know, it probably is specific to which instruments and what you call raw.
Yeah, like the high resolution Doppler.
Good question and specific. I'm gonna look to the sky and ask if Heath or Adam know if the high resolution Doppler LiDAR data are available on the ARM site.
Over to you, Adam. You'll get better.
Yeah,
guidance.
so are you asking about the spectra data?
Yeah, that would be nice.
So we can definitely set up collections for the spectra data and make that available. But any of the raw data we collect, you can always make a special request. So if you go to our data discovery, there's like a support or ask us button on there, and you can always request that raw data. We don't have it visible in data discovery as a default. So it's just a special request to get that data.
Thanks.
I'll also just comment that a lot of this stuff you can visualize with quick looks plotting and Doppler LiDAR data will definitely be a part of that. There's also, if you go to the ARM website, and I can happy to show you how to do this, you can request access to the folders where the raw data goes into, and ARM will let you get in there and look at that as well. So.
Okay, so, but it might take a request. All right. Kelly.
Strategies for the IoTs, building deployment strategies for any IoTs, is there like a frequency plan or?
Yes, I think the basic plan for sonde launches during IOPs is 4 per day.
Not sure.
Yeah, I don't know about the frequency of flights of the tethered balloon. I think that will be based on weather conditions and what the chemists are after. So the IOP sondes will mostly be then from the rural site in addition. Now, we could organize to try to do some additional launches in Beltsville, or if we wanted to send a student with a wind sonde down to Kent Island or something like that, we could probably do it. All right, Ben.
So I'm guessing we're not on some type of bet about being done at.
We're not on a
time.
bet about being done on time, but we don't want to go too far over so we have time to talk.
Well, we're already technically into 4 of the measurement.
We are
people's
not on
talk.
schedule. You are correct.
So I'll make this even more brief than I was hoping already. I'm talking about overview of the atmospheric composition from a BSEC centric perspective, and specifically particulate matter composition focus, because Glenn and others will be talking about long-term measurements that Glenn and Russ and et al. Will be talking about stuff they've been doing for a long time in Baltimore. So I'm just focusing on the particulate matter perspective in this talk. And I wanted to kind of frame just what Pete and I have been thinking the major questions and concerns are for Baltimore from a PM perspective, as well as what measurements we're doing. So the reason we're super excited about the intensive air quality measurement in Baltimore is if you kind of look at air quality studies by season, and this might not be accurate by scale, is you have these summer measurements that have been Mount Olympus size of observations that we've taken. Winter, you can kind of relate it to a house size for air quality, particulate matter composition, and then for spring and autumn are blades of grass. So we just are really missing this in-depth measurement of the particulate matter composition to understand how this impacts air quality and cloud and radiative properties. To the best of our knowledge, aerosol composition measurements that have occurred in Baltimore was during Discover AQ, where they were measuring nitrate, ammonium, sulfate, organic aerosol. There are long-term measurements that are located in some spots around Baltimore that don't quite get to the questions that we want. And there's been other measurements of like black carbon and total PM, but getting the exact composition so that we can understand its physiochemical properties to the best of our knowledge, last time was 2011. And why does that matter? And as I said, there are other ongoing measurements that have been in collaboration between University of Maryland, the Maryland Department of Environment, and NOAA that have both been flights and driving that will be discussed in the next talks, as well as the search site that Ken brought up. And this is a low-cost sensor network that gets us total PM 2.5 that Kristen Kohler here at Johns Hopkins has been running. But the why the huge length of time between 2011 and now matters is that there's been a lot of trends in decreasing precursors of these particulate matter, including decreases in NOx emissions, decreases in sulfur emissions. So this is impacting the inorganic aerosol, which would impact aerosol acidity and aerosol liquid water, which both impact chemistry within the aerosol, as well as its optical properties and cloud properties. If we look at some long-term measurements that are near Baltimore, but not within Baltimore, we see that sulfate mass concentration has been decreasing much more quickly than the nitrate mass concentration, while ammonium is staying relatively constant. So this has huge impacts in the aerosol liquid water, acidity, its potential as cloud condensation nuclei, clouds, nitrogen deposition in the Chesapeake Bay, et cetera. Another big thing that's been changing is the length of the growing season. So this was a quick figure I found that I think really shows the aspect that things that are yellow, orange, and red means that the length of the growing season has increased by 1 to 2 months around the Baltimore region. So this is not only forested regions where you're getting isoprene and monoterpenes that can impact secondary organic aerosol, but as well as applications of fertilizer and the associated emissions of ammonia and nitrate from agriculture. So we have all these complex things that are occurring at the same time, and we don't have detailed measurements of the aerosol properties to understand how that's impacting clouds and climate within the Baltimore region. And all this matters, as one example from Hennigan's group at University of Maryland, Baltimore County. They looked at how heat island effects, so Baltimore being hotter than the surrounding regions, can impact some of these physiochemical properties. So because of Baltimore being hotter, that raises the temperature and decreases the relative humidity, which in turn impacts how things are partitioning into aerosol and impacts your aerosol pH. So what this figure is showing is that in the rural areas, you have a higher pH because of the lower temperature and higher relative humidity than in urban areas because of the higher temperature, lower relative humidity. So having this gradient of measurements of the upland site and the farmlands and the BSEC site that I'll be getting into in a moment will help us start understanding what this gradient looks like and how that impacts the physiochemical properties of the aerosol. Another important aspect is how the heat island effect impacts the boundary layer height. So this was a paper that Catherine Travis at Langley, NASA, and I worked on that showed that the geochem model in red is not getting the boundary layer height correct in an urban area that we were looking at. This one is specifically Seoul, South Korea. So the observations of the boundary layer height are black and brown, gray. And this is partially due to not capturing the heat island effect and the heat flux. And this really impacts the model's ability to get aerosol chemistry right, as well as trace gas mixing ratios right, because of the boundary layers collapsing too quickly, that causes ozone titration much more sooner, which impacts not only the gas phase chemistry, but the aerosol chemistry and pH. So all this, if we tie it back to what ARM and DOE cares about, is all tied into the aerosol that gets into CCN that forms the clouds. So this is where our excitement is and will be part of the discussion this afternoon. So another thing of interest and makes this an interesting and complicated studies, if we think about the greater Baltimore, DC, Virginia area, we have this interesting interplay of an urban area mixing together between DC and Baltimore. The Bay breeze that can bring agricultural emissions from the eastern shores into Baltimore if things are thermodynamically playing correctly, as well as our typical westerlies that are bringing emissions from the Ohio River Valley, forested regions, and other things into the Baltimore region. So trying to understand how all this interplays to impact aerosol chemistry is important. So these were the questions that, at least from our perspective of PM mass concentration, is of interest. And this is where the BSEC stationary site that will be the downtown urban-ish type measurements will play into trying to connect that with the upwind rural site. So we're currently located at a temporary site that is near the Johns Hopkins campus. This is our inlet for measuring aerosol and gas phase. We also have a couple low-cost monitors there so that we can start comparing the low-cost monitors to higher grade scientific measurements so that we can relate what, for example, Kristen Kohler's site is seeing throughout Baltimore with what we're seeing with one location to have a better understanding of what that means for the chemical properties and physiochemical properties of the aerosol. So what do we have at this BSEC site? So we have a scanning mobility particle sizer for size and volume distributions. We have an ethylometer for particulate black and brown carbon mass concentrations. We have a time of flight aerosol chemical speciation monitor with extended resolution, or X. This gives us aerosol mass concentration, composition, and organic aerosol information at a 10 to 15 minute time resolution. We are measuring ozone and nitric oxide, nitrogen dioxide, and we are also measuring methane, carbon monoxide, and carbon dioxide at about the level of the inlet that I was showing you there, which is about 20, 30 feet above ground. Some new instruments that we're adding is a newer ethylometer. Right now, we're lending our own ethylometer until we get our new ethylometer. We're getting a new trace gas analyzer for long-term ozone, nitric oxide, nitrogen dioxide, et cetera measurements. And for some more intensive measurements, we'll be measuring formaldehyde and speciated volatile organic compounds with gas chromatography and proton transfer reaction mass spectrometry. This is also going to be in conjunction with one of the at least three different mobile laboratories that people have raised their hands about. Pete just recently got a mobile laboratory for Johns Hopkins I'm showing here that will have very similar instrumentation that we have at the stationary site, so that we'll be able to connect the two. We have a proposal in preparation to try to use this in conjunction with some other mobile laboratory measurements throughout Baltimore, and we'll be some of the work that we're doing is making sure that we're getting ground power at each of the ancillary sites that we can park there to connect what we're measuring in downtown Baltimore to these other sites around Baltimore during the CoURAGE deployment, as well as driving gradients from the rural area through Baltimore to understand how all these things connect. And we'll be working with the tethered balloon systems as well. And we'll also be working with NASA flights with potential flights that we're still trying to understand if possible for 2025. Real briefly, again, this is the relationship of the upwind rural site to where our current fixed site is in Baltimore, just to kind of get an idea of what the gradient will look like. And then this is where I couldn't quite remember, so I just put a big cross because I know it's still under discussion where the tethered balloon site is. So this is part of the reason why we've been arguing with where the tethered balloon system is, since we're going to be driving our mobile laboratory there. And the best way to do that is either head all the way south or all the way north. So this was very focused on what we've been thinking about. We know there's a lot of other ongoing measurements going on or modeling work, including Zhang and Ken Davis doing air quality, Kristen Kohler, as I mentioned, doing search network, Ren, who will be giving a talk about NOAA flights and mobile laboratory stuff, and 2 talks, Russ, who will be talking about stuff that he's been doing with the University of Maryland and modeling, Glenn, who will be giving talks in a little bit later, and all these other things with Beltsville, Pandora, Ozone LiDAR, and Aeronet. But if there's other ongoing projects or things that we're missing, or what observations or questions or goals we think are missing, that will be part of the discussion right after lunch that I'll be leading. And with that, I can take any quick questions.
Thank you, Ben.
How, I know very little about aerosols, but how can you tell that the pH of the aerosol, for example, is because of TNRH and not because of the original emissions that led to the aerosol being different between urban and rural?
So, the best way to get to aerosol pH at this time, just because of how small the aerosol is, so it's extremely difficult to measure hydronium ions the way we're used to doing in laboratory bulk measurements, is using a thermodynamic model. With the model, you take the composition of the aerosol and you need to have gas phase measurements of nitric acid and or ammonia to predict the partitioning of ammonia and nitric acid, because ammonium nitrate is very volatile, for example, and it depends on the temperature, relative humidity, and concentrations. So all these things is a nonlinear process that play into each other that impact pH. And right now, that's the best way we can get to
So
pH.
this is a model, not philosophy. Okay,
Right.
thank you.
One of the more interesting questions you alluded to is that as the composition of the aerosol has changed, the hygroscopicity of the interaction has changed. Are there going to be measurements of the hygroscopicity? Did I miss that? That's cool.
Yeah, so Akoya is going to be putting something at our stationary site. Something I breezed by real quickly is we're also have another proposal that is currently in review to do hygroscopicity type measurements at the rural site in April through June if it gets funded. Pete has some more comments.
At the ALS, get much aerosol for the operation system for deployment, there will be. Okay, do you have a quiz or investigator too?
Yeah.
Chief, he loves hygroscopicity. He's more of a meteorologist than I am.
So is there any plan for like a size segregating measurements, like particle size distribution?
So we'll have an SMPS at our site. There's size segregated at the rural site. I believe we'll be doing
There's pods at all sites.
yeah.
There's SMPS at rural sites, SMPS at the site. We'll have any SMPS on the lab. That'll be the.
Oh, cool.
Yeah. And it's going to be a similar type of mini one on the tethered balloon as well, right?
Yeah, possibly.
I thought there was an incense for the tethered balloon as well. Right. Yeah.
So those samples are hydrated or not hydrated?
So most of us are going to try to make sure they're dried, so they'll be dry size distributions.
Cool. Thanks, Ben. I propose we hear from Russ and then break for coffee.
Thanks, put me in between everybody and their.
Yeah, well.
All right.
Those almost emeritus professors, you gotta watch out.
Thanks, Ben. That's a really nice compliment to a lot of what's going on now. We don't have a lot of information on particle composition as a function of size. Very important.
There you go.
Right. Oh, and an old fashioned pointer. How nice.
Yeah. It won't advance the slides though.
Do I have to do that?
Yes.
Okay. I can handle that. So good morning, everybody. I'm Russ Dickerson from the University of Maryland, and for more years than I care to remember, we've been investigating the chemistry of first the global atmosphere and then focusing a little bit more down on the regional atmosphere. These are two of the mobile platforms that we use. That's our little Cessna and Noah's Ark, that kind of evil looking black SUV with the US government plates on it and all kinds of scary stuff sticking out the top. So when you drive that into Curtis Bay or something, people look at you kind of funny. But it's quite harmless. And Shinrong has developed that. He used to be a University of Maryland employee, but Noah stole him, but we still work together. So, so I give credit to everybody. This is, of course, a team effort. We have Tiberius and Ed are here today. but I won't have time to give everybody credit. Quick outline, I want to talk a little bit about what we do with the aircraft. And how we've helped understand the interaction of meteorology and chemistry to generate ozone and other kinds of pollution problems around here. We, Anacarians here, we work with NIST. They have developed a set of towers that measure CO2 and methane very nicely, and we do some analysis of that that helps understand transport as well as emissions. Shinrong, I thought was going to talk about the mobile lab, but that would take another hour. So I'll briefly describe that. It's been out there 3 years now. Okay, and so pretty extensive data sets. There's a paper that is under review right now that describes those observations. What we do not have is some of the stuff that Ben and Pete have, which is the highly resolved information on the composition of aerosols. So that's a beautiful complement there. The Maryland Department of the Environment with EPA money sort of has a mini BSEC that was funded last year. And if we ever get through the bureaucracy of things like QAPs, we'll have some more deployment there. And so they have some low-cost sensors in a couple of neighborhoods around here that have been operating. We work with Chris Heaney on some of that, who's, I don't know, somewhere here on campus. And they measure, well, I'll show you what we're doing there. And finally, my colleagues at the University of Maryland have a slew of models, starting with a zero-dimensional model, foam, that Glenn Wolfe developed, that's good for studying chemistry. We do WRF, oh, and I forgot to mention that Dalin Zhang, who is a real meteorologist, has studied the urban heat island effect and the circulation around here. And there's some interesting aspects to the meteorology of Baltimore, one of which is that upstream urbanization can impact the urban heat island effect in downtown Baltimore. It's a paper that Dalin wrote, and people are alluding to the Bay Breeze. This is extremely important. There was actually a tether-son experiment that went on before. I forgot to mention Gina Mazuka was actually an undergraduate when she did that. And there was some very fine structure. You can get huge changes in ozone at Essex, for example, Essex and Edgewood, in very shallow layers, 100 meters or a couple of 100 meters as the Bay Breeze blows in. One of the interesting things is fair weather cumulus clouds form over the land because it's hot. They don't form over the bay. What's that mean? If the bay's a smidgen cooler, that means you have faster photochemistry over the bay. So the pollution from Baltimore can roll out over the bay, fester all afternoon, and then blow back when the Bay Breeze sets up. So there's some interesting problems for the micro meteorologists out there. We mostly run CAMEX and CMAC for state implementation plans, the SIPs, and for source apportionment. And the Supreme Court's about to look at the Good Neighbor plan. Cities on the East Coast are never going to be able to attain the ozone standards unless the upwind states reduce their emissions. So we work a lot on that. And these are my colleagues who are good at modeling and remote sensing. All right, I better move quickly. This is RAMP. There's the website if you want further information. That's been supported by the Maryland Department of the Environment for decades now. And some of that nice improvement in air quality that Ben showed is a result of, we like to think, the solid science helping to drive policy. So we have good connections with the Maryland Department of the Environment, and the scientists there have had reasonably good connections with the governor and the secretary. And this has implemented things like the NOx SIP call, restrictions on power plants, better inventories, and so on. So unfortunately, there may be people online listening in from MDE, but I recommend you reach out to them because they can do high quality research. For example, in Piney Run, if you want a better background site, there's SODAR and LIDAR and air quality measurements at about 800 meters, a few hundred kilometers to our west. Okay, this is the airplane. It's big enough to carry a pretty good set of instruments. We can do total NOI, we can do NO2 and NO separately. We don't ordinarily do things like alkyl nitrates and pan. There's just not enough room, but we get the total. We can get gases with this candy cane reversed inlet and isokinetic sampling for aerosols. We don't get much in the way of aerosol chemistry, but we get size number distribution and black carbon. Well, we get scattering as a function of wavelength from which you can estimate size number distribution. And so here's an example. Last summer was interesting. This is another change as anthropogenic sources are improving. Fires, some of which are anthropogenic, are playing a really much bigger role, an increased role. So this is the carbon monoxide concentration. Ordinarily, everything would be blue, even downwind of the cities, but during this huge plume that blew in from Quebec, we were seeing up to a part per million of carbon monoxide around here. And that's the flight pattern that the aircraft flew. And this is the black carbon going up to several micrograms, thousands of nanograms per cubic meter. So this was a pretty nasty event, and we're characterizing that, try to figure out that, well, this shouldn't count against the state of Maryland in terms of attainment of the NAAQS, get an exceptional event, but that's not guaranteed yet. So fires are playing an important role, and the odds of during your deployment there being some smoke are pretty high. Oh, this is just fun. This is to demonstrate what we've done by combining measurements and models. This is a kind of snake and or spots and curtain plot. The curtain is the result from CMAQ, and these are total alkyl nitrates as a function of time, and the dots are what was measured from the aircraft. And you can see that the model is predicting substantially more alkyl nitrates than was measured by the aircraft. So what's going on? Well, the original chemical mechanism for CMAQ assumed that all alkyl nitrates would form into a certain category and have like a 10-day lifetime, which is clearly wrong. So Tim Canty and I and some other people worked together, and we improved CMAQ. EPA has since improved it as well, to put in some more realistic lifetimes for the alkyl nitrates. They can be photolyzed, they can be attacked by OH. And we got much better agreement between the model and the measurements. Why does this matter? Well, what is the spatial scale of an ozone event? If the alkyl nitrates are a half or a third of the total reactive nitrogen and they have a 10-day lifetime, then the ozone's formed somewhere over in Ireland. Okay, but if it falls apart within hours or days, then it's a local problem. So that's a really very policy relevant issue, and CMAQ has to get it right. Very quickly, this is another website. If you want more information, the data are available. This is FLAG-MD. Thank you very much, NIST. And they support our greenhouse gas measurements. Most of the short-lived air pollution is supported by MDE and by NOAA. But this is the same aircraft. It just shows you another place to get information on greenhouse gases. Oh, I should mention, this is done in collaboration with not just NIST, but also Stony Brook. Shepson has an airplane, brings a Duchess in, and we work together sometimes. And and Israel's here. Thank you very much. Israel's a very clever modeler, and he can take these observations and stick them into Stilty has a Lagrangian model that seems to generate remarkably insightful emissions for these stable species. There we go. Oh, and one of the most important discoveries that Shinrong made based on these observations was that the emissions inventories for Baltimore, Washington were low by a factor of 2 or 3 for methane. They were okay for CO2, maybe 15%, but methane was way off. And we got a lot of pushback at first, but since it's been discovered that basically all Eastern cities in the US emit 2 or 3 times more methane than was in most of the inventories. So we work together with Maryland Department of the Environment, and they have corrected those inventories, especially for landfills. They discovered a mistake there. And landfills may represent low-hanging fruit for improving greenhouse gas emissions. And I talked a little bit, there's Israel. He does some clever modeling there that I don't have time to discuss in detail. This is the EPA-funded MDE project that we have they subcontract to the University of Maryland. So these are the 3 sites that exist already for measurements of meteorology, PM in various size ranges. CO and black carbon, I've got not bolded out with a question mark, the ozone and NOx. I'm not so confident in the low cost instruments for oxides of nitrogen. They may be indicative, but the carbon monoxide looks remarkably good. So these are some good data sets. And the black carbon, I think, is really interesting. One of the hottest issues around is environmental justice. But if you look at ozone and PM 2.5, those are the things that we violate, the NACs. They're the same in Curtis Bay, which is heavily industrialized and has a lot of environmental problems. They're the same as they are in Potomac, where I can't afford a house, within 10%. But black carbon, that can be different by a factor of 2 or 3. So, and some of the other associated species with black carbon. Black carbon is a carrier for metals and a lot of stuff that has substantial health effects. So I think this is a really important, large scale problem at the community level. So if you're worried about the people that are least able to deal with poor air quality are the ones that have the worst air quality for specific species. But so we need detailed information, not just the mass of particles in the 2.5 micron range, and smaller. This is a picture not too far from here. It's looking south, a nice drone picture of Curtis Bay. And this is a residential neighborhood. People live there, they raise their children there, and it's surrounded by industrial facilities. There's a tank farm here. I can't see it, I hope you can. That's 100,000 tons of coal that gets sold and shipped out frequently. So it generates a fair amount of dust that annoys the people that live there. There's a lot of diesel traffic right in this neighborhood. A lot of diesel trucks going to that warehouse. And so, and a big power plant that's supposed to have been shut down, it hasn't yet, still burns coal. So this is a really hot area for environmental justice. This is an impoverished area and has a long history of severe problems with emissions. And we have a paper that's been submitted and hasn't come back from review yet. Noah's Ark. Oh, good, you can see it pretty well. The hotter the color, the more black carbon that's on there, going up to 2 micrograms per cubic meter. And where are we? Somewhere up here right now. But you can see some hot spots. Here's Curtis Bay and Turner Station, the downtown area. So this is work that was done by Shinrong and some of our graduate students. And then Hao He ran WRF at 0.4 kilometer resolution. And this isn't strictly comparable, but he just said, okay, can we run CMAQ for black carbon and get anything that begins to look like the neighborhood level? And you can see the hotspots are observable on there. So we have some hope that CMAQ might be able to represent black carbon. These aren't exactly the same day, but it just gives you an idea of measurements and models working together. So try to keep it short, and I can ask for questions. So this is a summary of what we're up to. And I think some of the more interesting questions is, as we get information on exposure and composition of trace gases and aerosols, we can ask, what are the health impacts going to be? How are they going to vary? What's the exposure? Going from concentrations to exposure is a challenge. It's rather difficult to model at the neighborhood level, but we can get down to 1 kilometer or better. We have no information on greenhouse gases N2O. I think the DOE deployment will have a nitrous oxide measuring device. That's something useful. Secondary organic aerosol, what's in the standard EPA, CMAC, chemical mechanisms, they don't do not very sophisticated for SOA. So this is a great challenge. We'll have good information on the organic aerosol, but how do we model it? So that would be a good challenge. What are the best meteorological fields we can generate? That's going to be a substantial issue so that we have better local and regional representation of our air chemistry problems. So yeah, I think the take-home message is there's a beautiful complement. There's a lot going on, but there are a lot of things we have not done in the past, and CoURAGE and BSEC are going to bring those. And I think we'll learn a lot. And the most exciting, I think, questions we can ask ourselves is what are the likely impacts on the hyper-local scale, on the community or neighborhood scale, for black carbon, diesel exhaust, and the other pollutants that have substantial associations with morbidity and mortality. So that's it.
Thank you, Russ.
Yeah. And here's you can get a bibliography there, and these are the papers that we've written in the last 5 years. Sir.
Russell, you were talking about how to go from basically hazard to exposure, and I think also Ken was talking about indoor-outdoor measurements. Are you planning indoor-outdoor measurements to look at the difference in air quality exposure through this project?
We do not have systematic indoor measurements anywhere, but Ben has.
Okay.
So that's why I'm calling the site that we're at a temporary site, because Ben, SciCheck, Key et al. Are working on trying to find a representative row home in Baltimore that will become our permanent site that will have every 15 or 30 minutes we'll switch from measuring indoor and outdoor. And part of the experiment that we'll be doing with the row home is what upgrades can we do to a typical row home? How does that impact the air quality?
Yeah, that'd be a unique new set of observations that I think
there are some interesting measurements that were done on heat exposure indoor and outdoor, and there's quite a bit of difference, but that will happen.
Yeah, there's some good work on the urban heat island effect in Baltimore that I don't have time to show right now, but we've got a pretty good, Baltimore has a fair number of trees, but we still have a substantial urban heat island problem. And it correlates, it's usually the neighborhoods that have low income, high minority populations and fewest green space. So these problems all compound.
Good questions. I propose we come back in 15 minutes. Stop, get coffee, etc. Don't go away if you're on Zoom. We'll be back shortly.
And that comes.
Oh, great, it's in Jorge.
Yeah,
Okay.
Long time ago, yeah.
A while ago.
Yeah, it was. A nice talk. Well. No, I was existing for that, let's see conference, I think we are at, yeah. Yeah, I mean, that was my only time, yeah. Since then, I typically working in Vietnam, papers, but that was my only class.
Yeah.
So we do have
No, I mean, yeah, I mean, right now I thought it was my American passport, so at some level, anyway, but yeah, no idea what. There, I don't know, I haven't with my American passport. When I traveled there, I only had my Lebanese passport, and I got all of, weapon and all that. Anyway, nice work. One of my favorite people. Yeah, he is. Yeah, he is. He is fun to work with also.
Oh, yeah. I'm going to negotiate here for 40 years.
Well, I should not have to. I have some very early experience with them at the more than years ago.
Well, it's simulated if there's more in there, then we start getting into.
Yeah,
all the
years ago,
fun,
we just
that
started
might-
to. Well, maybe.
We can do this guy doesn't sound well, he's doing, it's a real meeting model for like experiment. Either how do I, you know, from the gas guy that you like to go. But if one's more in there, yeah, you can whole fiasco. Or the, all the documentation has been modified. So doing experiments with people. You can run it, you know, scientists. But you don't have any.
I do, yeah.
So we were at those recent camps. The correlation between models, so we were working on observation. So there's, there's a limit. You can make the meteorology better, but that doesn't necessarily mean.
Yeah, I think like, 10 years ago, students also started this effort of having so good.
Yes, yeah, that's been around a while.
Yeah, so it helps. Well, for example, climate, once you have input, I have like turbulence information, like random.
Yeah, but I think Lumen Grid is really a like.
Actually,
It doesn't actually resolve the Lumen itself. It just says, okay, we know that there will be a subgrid scale plume from this power plant in this grid. And it will have this non-chemistry.
So like kind of semi-analytical.
Yes. Only it doesn't resolve.
I don't know, like I've had the errors in there.
You need 100 meter resolution for that. That, you can do that for everything.
Yeah. Right. Nice meeting you.
I don't know. Maybe I should do
Obviously, the depth from right now. In your project, so
Yeah, there are tools that already exist. I guess I like the niche will be stays somewhat.
I think it makes sense. There's so many formats. That's fine. There, it's just true that. Human real.
So all the things I write out on, in my work, so I take in from any data source, but then I just end up writing it very clear to read it. Yeah. So that's. Everybody.
Yeah, everybody.
May not be the dishes.
I mean. It's standard method like that. But yeah, I think it's. As long as it's standard. And that's the there's nothing. But it's not. They do have file. Yeah, it's something else, but there it is. I have it. Yeah. I think there's. That's 2 steps.
I'm in Charlotte. Yeah, how's the work going? One big deal. It's I'm sorry. Yeah, it's sort of the work.
You can go with. Verify that everything.
Yeah, I was wondering, maybe one of the early meetings, I do urban participation, but I'm gonna have to run with the ordinance to make sure. So I will be in this. Unfortunately, oh, I'm sure. Your, Jill. Yeah. Yeah, I'm gonna see that, and like.
Right there.
Yeah, that's the most, so we both do urban.
I understand.
Yeah. No, it's a lot, everything forward. Oh, she's doing great. He's you don't really understand. Oh, yes. Yeah, so I think he's at, there's another science computing going on there, at UConn. Or they're also urban folks, they have more on building it. You probably, so he's at that level with our. Yeah. So yeah, I'll look at that. Eventually, it's getting closer. I guess you're supposed to be. Schedule. That's
It's supposed to be a breakout session. I think that's what I did.
Yes, yeah.
But I was looking at this. I think
you could get another.
I mean, I already see much. I think it's kind of stuff.
After Harold, he's really he's leaving because since I don't know who else is doing.
You didn't know. Oh, okay. Okay.
I will be inheriting a lot of those work stuff. Like even from being inheriting, I'm still, insane. I'm still very much. Sorry. Yeah, he's really I'm sorry to say, he's really the only one right now that has like that level. He's. Yeah, I could definitely help him to be like, hey, like, but, yeah, I know how, like.
So we are Grand University of Albany. Grand University of Albany, Harold is a little bit special because he's at. If you live in both, so he's not like, he's not going through his office. Are you considered that? Which, oh, shit, okay. We're using right now, so for my work, I'm using, yes, yes. Sorry, it's it's about the camera. It's, the assistant, for example, what is it? Settings, like, you carry something when they're all night, but if you have on your head, yes. I don't know. No, yeah, but one kilometer, okay. So then with yeah. Let's say that maybe driving 6 or 7 hours. More likely, yeah, but for him, it's not, yeah, because I'm about to learn the same issue.
Okay, who's next?
Yeah. Yeah. Yeah, I know. I will definitely.
Oh, who's next?
I don't, this more day want to get it with your colleagues. But like, so we'll be in there. What's that? Yeah, I'm, yeah.
Shinra. And then Glenn.
Oh, the Jason.
Okay. You know what, Jim, wrong with you? So I don't. Yeah. Yeah, that's what we'll do. Okay. Thank you. Yeah. Length is not our friend, but you got the time now.
Oh, okay.
Yeah.
Yes.
One more pull, Shinron. Let's get started. All right, Zoom land, we're back. Next up, Shinrong's gonna talk to us about NOAA flight plans for the summer, maybe other stuff, but I think we have NOAA flight plan. Go for it.
Okay, yeah, so I'm Xin Rong, I'm a chemist at NOAA Air Resource Laboratory. So I'm going to talk a little bit about the air maps project we proposing for next. So the air maps actually it's a 5-year survey, NOAA's a 5-year survey, so we'll mainly focus on the two areas. One, the urban and some urban cores in the US. The other one is the oil and gas operation fields. So we are going to use a bunch of platforms, mobile lab, stationary measurement, and aircraft and satellite, as well as possibly the ship measurements in the Gulf of Mexico. So and we have a bunch of partners listed over here, mainly the state level of environmental agency. So here's a map showing the so that there's a timeline and the different colors shows the five different years and the area we are going to. So this year, this summer going to be the first year we are going to go to survey the Denver-Julesburg basin as well as the Salt Lake City, and the next year going coming back to east to look at the DC Baltimore for air quality, as well as a Southwestern Marcellus for the methane emission from oil and gas operation there. And then the rest year will go to the 2026 going to go southwest area, as well as and then 27 for the west, 28 going to come back to east again. So focus on New York City, as well as Chicago, Indianapolis, as well as the entire with Marcellus. So for next year, so we have we are bringing the NOAA Tornado and Tornado aircraft, as well as the we have the UMD Cessna, and have NOAA's Ark mobile lab, and we will have two focuses. One is a Baltimore air quality survey, as well as the Marcellus methane survey. So here are just a few objectives. I think I already mentioned that. Just go quickly. And here's a few. We are going will collaborate to the different agencies, as well as the academic institutes on different themes here. So here's the payload for the NOAA Tornado. So it's going to have the we have the Doppler lidar to measure the vertical wind speed and wind direction at different levels. It can look measure upside or downside. So can especially if we are flying within the boundary, you can basically measure the wind speed and wind direction. And we also have the airborne max thrust to measure the column density, column of the NO2 and mountain height. And we have a suite of trace gas measurements for air quality and greenhouse gas. So we request about total 150 hours, and I guess probably will be 90 hours will be in DC Baltimore area and 60 hours for the Marcellus for next summer. And here's the, I think Ross shows this already. So, we have the Cessna going to be fly with funding from MDE expected. So has the trace gas measurement and some aerosol optical properties and black carbon measurements. And for mobile lab, pretty much the similar instrumentation with the greenhouse gas measurement as well as some air pollutants, ozone, NOx mainly, and particles. And here's just a few examples. So we are going to mainly fly two kind of flight patterns. One is for mass balance flight to quantify the emissions of this area of greenhouse gases and maybe also some air pollutants. And the other one will be most of for air quality. So depending on the winds and the meteorological conditions, we may fly over Baltimore and maybe over the Bay. So this is just one of the flights we did, I think, last year. So we'll follow some. So we'll do spirals, and at the local airports, we are going to do a low approach. So try to get to the virtual profiles of the greenhouse gases and air pollutants. So because we have the airborne Doppler lidar, so certainly the wind during this flight, we will have all the wind measurements, within boundary. Yeah. I think that's all. Yeah. Sorry. See one more. So 3 slides more. So since I come from the air resource lab, our lab actually also operates the it's called the UrbanNet. It's the mainly right now the sites are mainly in DC area, Washington DC area. So it's for the climate and meteorological measurements. So this is one site on a full building in downtown, just next to the White House. And here are some measurements of typical meteorological parameters, as well as this is the NOAA NIST lidar on top of that building. So the data is 24/7 it's measuring, and we plan to have up to 8 sites of the UrbanNet sites operational by in the next few months. So data will be available during CoURAGE campaign. So this is a map. I think it's also combined with the NIST tower as well. So I think that's all I have. Yeah.
Thank you, Shimon. Any questions? I have one. The lidar looks up and down from the twin otter, right?
Yes.
So I was going to say, what flight altitude are you at?
Yeah. So we will do I think kind of two kind of. So one would be visiting the boundary. So kind of looking up.
Pointing it up.
Yeah. So depending on the yeah, and the other one will be fly above the boundary. Will be looking down.
Yeah.
Yeah.
I've not seen a whole lot of upwards looking. Some, but not often. You don't often find upward looking lidar for background. All right.
Yeah, but it's it's
Gotcha.
It's available. Yeah.
And ethane, cool.
Yeah, we're going to have ethane measurements.
Just the car over there?
No, this is the areas right now, I guess, for ethane. Yeah, right. Yeah.
Still working.
Yeah. So yeah, we are it's going to have in flight zero and calibration system on board. Yes.
I just wanted to point out, because I used to work with the people that put the lidar on the otter. The downward and up pointing is relatively recently added capability. Did that during the California Fire Day this year. So there are some resources there that you can look at to see what we can get from that. And then also the recent Cupid's measurement campaign which I think there's quite a few resources that show that.
Yeah, in New York City, last year they had a very good measurements with the same system. Yeah.
Could you use that to get some information about high altitude divergence that would be interesting for deep convection? If you have
Possible,
anything out
I'm-
there to get a bounce back on something.
Guys, I'm not a meteorologist, so I guess it might be possible, I guess.
That's a question for Ed.
Yeah, it's pretty pristine up there. I'm not sure.
I don't think you have, how do you have a pyro CD?
I don't think you would see that, no, but I could be wrong.
We do some days.
Would you be better off with the radar?
And
I was just gonna ask, since you talked about the Cessna and the Sonata, they'll be going at the same, like, together.
yeah, they're going to have some coordination, yeah,
So
together,
you're
yeah.
different, like you mentioned the AIRS, I know you do have an AIRS instrument on the UMD aircraft. And then there will also be another one on.
Yes, we have, yeah,
There'll be
two sets, yeah.
um,
All right, great. Thank you, Shinran. That's very helpful.
Okay.
We can talk more this afternoon about how to coordinate stuff.
Yeah.
Next. Glenn, I can get Glenn's slides up. There we go. There you are.
Thanks, Ken. Right. Hi, everyone. As I said this morning, if you weren't here, my name is Glenn Wolf. I work at NASA Goddard Space Flight Center. And I am the PI for this mission called Associating Local Emissions of Gases with Regional Observations from Satellites. Work at NASA, so we love acronyms. So I'm going to tell you about this. These flights are going to start in less than 10 days. So, and I thought I had fixed this stupid text, but I guess I didn't. That's okay. All right. So Allegros is actually an add-on to another mission, which is the Student Airborne Research Program.
I can get rid of the floating meeting controls there anyway.
Yeah, I swear I fixed this on my computer, but. So the Student Airborne Research Program is a summer internship that's been running for over a decade by NASA. So it's for rising senior undergraduates, and we expose them to all aspects of airborne science. Typically SARP leverages whatever aircraft is available. This year, they didn't have any in situ air quality type payload missions running. And so they asked my group to help run this. And so I'm going to tell you about what we're doing with a small aircraft. I just want to mention up front, there's actually 2 aircraft flying. There's also a NASA P3 that has a radiation and aerosol payload that'll be flying in the same area at the same time, but very different flight profiles and instrument suite. So our motivation for this is twofold. So Tempo, if you're not familiar with this is a geostationary satellite that just launched last year. And it provides very high spatial resolution hourly measurements of air quality gases like formaldehyde and nitrogen dioxide, and maybe surface level ozone. They're still working on that retrieval. And this is a measurement, an example of the Tempo measurements from August 19th, 2023. And that's a single hour of data, and that's NO2, tropospheric NO2 columns. And, you know, if you look at satellite measurements all the time, you would think this is actually really quite remarkable to get this high level of information. But Tempo is not well validated right now, and retrievals are very complicated. There's a lot that goes into them, and the higher the resolution, the more careful you have to be. And so we want to provide some data to do those validations. Another motivation is that there's this nascent effort called the U.S. Greenhouse Gas Center, and NASA is helping lead an interagency effort there, and that kind of covers all of greenhouse gases in all of the United States. So that's a very broad topic. But in the documentation that's out there, there's a lot of discussion about needing higher granularity in space and time for greenhouse gas emissions from a variety of different sectors. So what we're going to do is we're going to equip this aircraft. This is a Dynamic Aviation B200, so it's not a NASA plane. It's owned by a contractor. It's about the size of a Twin Otter, so it can kind of hold the same number of instruments as what Jinrong showed you. And our payload is pretty much all in situ gases. So we have carbon dioxide, methane, water, CO, formaldehyde, NO2, ozone, and then we have volatile organic compounds from a full air sampler. The greenhouse gases are from a set of Picaro instruments, and the other instruments, these are a little different from what you might see at the monitoring station. So these are research grade, custom built instruments that we built in our lab to do airborne measurements throughout basically the entire troposphere and stratosphere. And importantly, most of these instruments are capable of doing eddy covariance, so they have sufficient precision and time response to do that. Typically, what we're going to be doing is sampling at 1,000 feet. Occasionally, we're going to profile higher because we need to know where the boundary layer is, and the flights are going to be relatively short. This is an example of a flight plan that we would do over Baltimore. And by the way, this here is just to give you an idea of the size of that tempo pixel. So you would get a lot of those in the Baltimore area as opposed to like 4 or something for an OMI pixel. So we'll be based out of Martin State, but don't tell anyone that because it's not very secure there. But we're going to go fly around some landfills there, and then we have a ground-based Pandora spectrometer that we've located at the Essex MDE site. So that works very much like tempo, except it's looking up instead of looking down, measures the same gases, but every hour. And so we'll go there. We will spiral over that to try to get the vertical column that it's measuring. And then we come down to the south here. We would do these power plants, and then basically we're just zigzagging back and forth at 1,000 feet, rastering this whole area. And the background map here, by the way, is the Hestia CO2 inventory, which is a 200-meter resolution. And so, you know, that's another motivation for doing Baltimore as well as Los Angeles, is there aren't many places where those high-res inventories exist. So we're going to be, this will be the 17th to the 22nd. We'll be based out of Martin State, and we'll be mostly focusing on Baltimore. We'll do Philadelphia if we can, so I have other flight plans for that, but it'll depend on weather. We have about 30 flight hours allotted for that, so that's actually a lot of flying in 6 days. And then we will go over to Wallops Flight Facility in Virginia for SARP East, and that'll be a little bit different tempo because we're going to be putting students on there that haven't flown before. We'll be hitting Virginia, which is, you know, these hotspots down here. This is Norfolk, this is Richmond. And then we might also try to get back up to Baltimore for 1 day during that time. And then we go over to SARP West on the West Coast here, and there you can imagine flight plans like this, except over the Los Angeles area, which is a much more complicated airspace, but also much richer number of targets. So we'll be doing the cities as well as some of the rural areas to the north and south, where there's just a lot of oil and natural gas. There's a lot of dairy and cattle, crops, and so on. So as far as science objectives, we're, you know, the main thing we're interested in is understanding the horizontal and diurnal variability. So, you know, when tempo sees a gradient like this across the city, do we see that in the airborne data? Does that make sense? Or is there some kind of artifact? You know, for example, there's probably serious issues with clouds right now in the retrieval that we need to understand. And do we see the same diurnal cycles, right? So tempo is measuring every hour, and we're going to try to do 3 flights a day so that we can capture some of that. And I also mentioned, so we want to evaluate those retrievals, also the Pandoras. So, you know, there's only one here, but in these other locations we're flying, there's, you know, maybe 10 or so Pandora spectrometers distributed throughout there. And the Pandoras are theoretically a major validation strategy for tempo, because you can put them somewhere and they can measure a long time. But the Pandoras are not well validated either, right? And so we need to do some more work to make that connection. And the people who run the Pandora network are based at NASA as well. Another thing we want to do, and this is where the eddy covariance comes in, is evaluate emissions inventories for NOx, CO2, and methane. And I'll show you an example of that on the next slide. And then I'm also interested in urban ozone deposition, which is this kind of funny topic that hasn't been really explored. And then, of course, flying the SARP students is important too. So let's see. Arrows. All right, there we go. All right. So I just had one slide to give you some idea of what we might do with this data. Recently, we did a mission called Asia AQ, which was over in Korea, Thailand, the Philippines, and Taiwan. We're flying on the DC-8, which is a much bigger plane, but we're looking at a comparison of our data against the GEMS satellite instrument, which is just like tempo, except over Asia. So this is formaldehyde from our in situ measurements, this is formaldehyde from GEMS. And just the fact that we have a line is actually really surprising. And so this is very preliminary analysis, but this is the kind of thing that we'd like to be able to do, but at much finer spatial resolution over Baltimore. And then another thing I mentioned, evaluating emissions inventories, and this is just to show you that this is possible. So there was a mission called RECAP in 2021 in California, where they did these kinds of measurements of NOx and VOC emissions. And this is an example of the measured fluxes of NOx over the Los Angeles basin. So you see a nice hotspot up here. And then this is an inventory, and I don't know if this is CARB or NEI, but the inventory, there's some dramatic differences here. So much lower values here, much higher values here than what the measurements are reporting. And so this is a way that we can get very high resolution information on these emissions and how they vary, and also how they co-vary. So we'll measure NOx and CO2 emissions at the same time. So now you can start to pick apart sources maybe. And then as my final slide, just mentioned, I think all these have been mentioned. We have connections with all these folks. The mobile lab, hopefully we fly driving in the area while we're doing that. I mentioned the greenhouse gas center. I don't know that we're going to do this next year. The SART plans vary year to year. And unlike air maps, I don't have a 5-year plan. I've got a 5-month plan at best. But if we can do it again, I'd love to get up again. So that's all I have. Thanks.
Thanks, Glenn. Question, Glenn. Anna.
What kind of spatial resolution do you get, or do you believe the eddy flux measurements from the airplane?
Yeah, the footprint is about 1 kilometer. It depends on altitude.
Right.
It might be a couple kilometers. It's altitude and wind speed dependent.
So where you typically fly, how high do you typically fly?
We'll be at 1,000. We can't go lower than 1,000 feet
1,000
over
feet.
urban areas.
That's about 1 kilometer then.
Yeah, again, depends on the wind speed and stability. So if it's a cloudy day and the atmosphere is stable, that footprint's going to get much larger. But it can be hundreds of meters if we can, in Florida, we get down to 300 feet and they can be small. Yeah.
But your sampling then is like an eddy or two, right?
Well, it's a frozen eddy hypothesis. So you kind of collect all the eddies at the same time. That's where the wavelets come in. So we use the wavelet transforms to pull all those eddy pieces out. So that's what lets us get the horizontal resolution. So yeah, it's different than if you're stationary and the eddies are coming to you. It's like you're coming to the eddies.
Yeah, I would love to look into that because I'm an old student of lunch hours.
Okay.
100 kilometers was the basic.
Yeah, right. Well, we like 30-ish. But they used to do it, they would do block averaging like you do for a ground-based measurement.
Interesting. You don't want to go down that rabbit hole.
Russ?
Yeah, I had the same question. So you get that kind of high spatial resolution as a snapshot.
That's great.
Okay, so you need, right, as you zoom over, you might like several snapshots.
All right, sure. We do it a couple times a day. Well, we also tend to repeat lines occasionally, just to look at the statistics and make sure we're kind of measuring, that our error estimates are accurate, because most of the error is random. But
Used to be at least 20 minutes of buzzing around here.
when you were doing block averaging, we don't do block averaging. It's the wavelets get you away from having to do that. Yeah.
With the tempo, like hourly measurements, what's the horizontal footprint like?
It's like 2.5 by 4 kilometers. And that's, hourly. So for NO2, that's probably the hourly measurements are good. Formaldehyde, the retrieval is tougher, the cross section's weaker, and so they typically average them to 3 hourly resolution, or you could spatially average them down. But you need some way to beat the noise down typically. Yeah. Thank you.
So for the flight path that you design,
Mhm.
is that you're gonna need to keep it as like fixed for a certain area, or it actually depends on some of the weather conditions, or?
Because of the airspace and the fact that we have to shop this around to ATC first, we probably won't nudge those too much. And there isn't a lot of value to nudging them that much anyway, but we would meteorology determines the way we fly. So I have another plan that goes north-south instead of east-west. So we'd like to have the vertical wind, or sorry, the horizontal wind kind of across, right? So that your footprints are actually separate as opposed to overlapping footprints. So, you know, we would pick one of two depending on the day. Yeah.
Thank you very much.
Thanks.
All right. So that's, I think, most of what we have for people who are going to talk about measurements coming up. There's others, I think, that are, we could hear about. For example, we were going to try to get somebody from the Beltsville group to talk with us, but most of the people who could tell us the most aren't available right now, like Ricardo is out of town, Belai is out of town. So we'll have to catch up with them at future meetings to get their input. And so next we're going to go into, and if anybody's got more measurements for 2025 that you want to bring up, this would be a good time. If not, we're going to move into planned analyses. Talk about what people have for analysis plans. And then discuss what we need to do. I am up next and I'll be really, really, really fast. This is just a snapshot of work that's going on related to atmospheric dynamics connected to BSEC. And it's just literally one more slide with a few names and a couple topics, just to give you an idea who's doing what. So we have, as part of BSEC, which again is kind of a foundation of the analysis that we have for the CoURAGE effort, a number of different model data and modeling efforts underway. Elliot Faust, who's online, is working on city-focused urban heat. Jason Horn, working with Yingpan, who is online, is working on WRF LES, again with a surface heat focus. We also have Madad Talibpour, who is at Johns Hopkins, is working with Ben Zaitchik on a different version of WRF LES with a more of a focus on soil and soil moisture and lateral flow in the soil system. And those probably are not going to focus on CoURAGE time period, I think. But the folks, the darker color probably will have more of a focus on the CoURAGE time period. And Nick Prince, who is online, is doing WRF regional mesoscale work. He's also been working with our BSEC LiDAR, and he's just getting underway. Caitlin, who's here working with Kelly, is probably going to be studying storms and precip like last night. Except for, yeah. Ben, Larry Band, Dan Rasciuto are all running land surface models, and everybody, of course, is running, WRF is running a land surface model too. And so we want to care about how the land surface models work. And Gil Wren, who Ben already mentioned, is helping to bring together what exists in the area for air quality modeling and perhaps run some of our own air quality modeling. That's it, just a list of resources and people who are engaged in some of this work that comes out of BSEC, but will connect into CoURAGE. Questions there?
All this simulation, is it like planned for like total 1 year AMF one
No,
scale?
it's not all that. It can't just line it up like that. No. So my answer is no, but I'm not going to tell you what all the times are, because I don't know them all and it's too complicated to answer. Some we could do that way, like the regional WRF mesoscale, we probably could run a full year, yeah. WRF LES over neighborhood, no way, we're not going to do that. Storm simulations, maybe more focused on events, for example, rather than trying to just do the whole time period. Even things like the heat might be just a heat wave or a season. So TBD to a large extent. Maurice.
Has the list of times for the model been like determined? Or
No.
is it something that's after the intensive?
TBD. Yeah, this is people's dissertations, and we'll see what the measurements are, and this is the kind of stuff we can talk about. This meeting would be a good time to say, it would be really great if we could do the following and try to get that planning going.
Are you planning some more simulations for the IOPs?
So same answer.
Okay.
TBD. Yes, sounds reasonable, doesn't it? Good idea. Let's talk about that more. Okay. So then I'm gonna stop. Told you I was quick, trying to be. And who's up next? Who's got the agenda handy? Are you Israel?
Maybe, yeah.
You might be. If not, come on up anyway. And let me get this in show mode. There you go. All right.
Thank you for the title, Ken.
Yeah, speaking of wharf simulations.
So, thank you everybody. I'm Israel Lopez Cotto, and I'm going to present some of the modeling.
Oops. I see a hand raised.
Yes, go ahead.
Can we get that? John, do you have a question before Israel gets going?
Yeah, sorry, Ken. I had my hand up. I was gonna sort of end on the observational analysis or with observations with the toolnet slide that I had submitted.
Oh,
okay. And I think I might have been overcome by the analysis efforts already, but
No,
if you've
that's all
got
right.
a few
You might
minutes
be given-
before or after.
It's fine, yeah.
Yeah, sorry about that, John. I thought that you were, and I didn't, then, yeah, my apologies. Let's get your slide in there. There it is. Thank you. I thought you were on the agenda and then I didn't see on the agenda and I got kind of confused. All right, you got it, John.
Yeah, and I'll be really quick. Thanks. And this is a good follow-up to, I think, Jinrong and Glenn and Russ's work. But really, I just wanted to mention that we're also looking for some potential toolnet deployments for summer of 25 during the CoURAGE IOP. We will largely, I think at this point, try to follow the aircraft flights from the CSL group and the ARL flights / UMD flights. So this would be focusing more on the atmospheric composition component of the CoURAGE proposal that I was just reading yesterday, and seeing a lot more in there about atmospheric composition. So I'm the project scientist. I'm John Sullivan from the Tropospheric Ozone LiDAR Network, or TOLNet, which you might hear. To get to kind of, I think, the point here, we've got a larger sort of TOLNet observatory that is based out of NASA Goddard that we have deployed to the Beltsville site many times in the past. Actually, you can see a curtain of ozone LiDAR there in the center, courtesy of a publication from Maurice Roots, who's in the audience. You can probably follow up at lunch with any additional questions. But generally, we've got nearly continuous ozone profiling during certain events of interest. We generally have ozone SON capability, surface ozone NO2 MET. We generally bring a salometer with us. The picture there on the right is actually during the tracer, sort of pre-tracer or tracer AQ campaign. Kudos to Heath and Mike Jensen and those teams for supporting us on that activity for a lot of the infrastructure. So we have a sort of a major TOLNet trailer that can house we have a lot of space in there for additional instruments. So I wanted to plug, if anyone's looking for additional space to house anything, we generally can do that. In the past, we've had small sensors on our roof, intercalibrations going on our roof, etc. We will probably, due to the size of that trailer, either be at Goddard, which will be no cost to anyone, Beltsville, which might be a minor cost to get the transport there, or UMBC, where we were in 2018 for the Owlets campaign. So that's sort of the Goddard portion of TOLNet that I wanted to describe, but breaking this out larger into TOLNet as a network, we have developed with our colleagues at NASA JPL a small ozone LiDAR, SMOL, small mobile ozone LiDAR. This is a sort of a refrigerator size ozone LiDAR, small, portable, 20 amp breaker, very simple to deploy. We've had these operating for about a year now in different locations. We're supporting the Salt Lake City study this summer with the NOAA CSL group, and the hope is that with a little bit of funding either internally here, or maybe if there's a collaborator on the line that has interest in this, or potentially the state of Maryland, we could bring these for relatively low cost and complement. If I had to sort of identify the sites, it would likely be this Baltimore core facility, the Bay site, to pick up some of the ozone transport over the Bay, and then potentially either at UMBC or Beltsville, whichever site the larger Tollnet Tropos system cannot maintain. So that's all I wanted to say. I wanted to just make sure that folks had this, if they're interested in ozone, like I said, I was reading the proposal yesterday, and I was impressed by the amount of atmospheric composition that is still in that proposal. And then one other thing with not mentioned here is the Pandora network without the throughout the region will also be able to provide some complements to the atmospheric composition. And we also support many of the Pandoras out of NASA Goddard that Glenn mentioned throughout this Baltimore corridor. So thanks. Like I said, feel free to talk to Maurice in the room. This is a figure from his paper, and he can be the sort of the expert on this paper was understanding some of the ozone transport that happened right after a nocturnal low-level jet, and that redistribution of pollutants in the areas is really key to understanding the combination of chemistry and dynamics in this kind of complex urban region. So other than that, feel free to, I'll be around in the chat throughout the rest of the afternoon, but thanks for the time, Ken, appreciate it.
Yes, thank you. Sorry, I missed you earlier. Glad you spoke up and raised your hand. I'm looking at the chat now. And questions for John first. There's one in the chat from Joel. What's the lowest height gate on the small ozone LiDAR? $100-meter-ish.
Yeah, 100 meters ish. So Russ mentioned earlier some of the complex ozone chemistry that happened in the first 100 meters, and we would love to actually, I don't know if Ken, if you have an answer, do you know if the tethered balloon system is still going to be at the base site? Is that the plan right now?
No, FAA restrictions say no. It's going to be on the bay, but on the eastern shore is most likely.
Okay.
Right across the bay from Baltimore, but a long drive.
Kind of near Tolchester Beach, John, I think.
Okay. And will that have any chemical sampling on it, or if we provided an ozone sonde, could that ride on the tethered balloon sonde payload?
It will have chemical samplers on it, and guest instruments are a possibility. You'd want to put in a simple little proposal, I think, 2-armed, to say we'd like to put this on the sonde as a guest.
Okay. All right. Well, I'll follow up with an email now to you, and we don't have to do that now, but it would be really helpful to have an ozone measurement on the TBS for the Tolchester Beach side.
Okay. Yeah, this TBS won't be there for that long a time, but yes, I agree. It'd be lovely to see one of these at Kent Island and in downtown Baltimore too. That'd be fantastic if we could figure that out. Russ.
That tethered sonde, that went up to 1,500 meters?
Yes.
Okay, so that's the problem on the western shore, that you want to get high and FAA says that's too high.
Reagan National Airport, 45-mile radius, I believe. They've decided no flights.
Okay.
And yes, the flight altitude is, too high for whatever that is. Usually it's upside down layer cake, 1,500 meters wouldn't matter, but.
Because we did that.
Yeah.
A few years ago.
I'm not fighting that battle. I trust that ARM tried.
Yeah. They're probably right.
Great. Thank you, John. This is cool. Let's find a way. That's my quick answer. All right, now. Israel. Your turn.
So
Take
way too many slides, so maybe give me 5-minute marks when we are, so we can.
Okay, I'll try. All right.
So I'll try to be quick. As I said, I have too many slides, but anyway, I think we will get to the main points of the talk today. Yeah, we're gonna be talking a little bit about the atmospheric modeling we are doing in the Northeast Corridor. Before going into that, I want to say why we care. We care because, as you may know, NIST has developed this 3 urban greenhouse gas testbed system, highly instrumented networks with a cavity ring down spectrometer to measure CO2 and methane. The objective of this testbed is to develop, test, and demonstrate greenhouse gas emission techniques and then to, everything that gets associated with it, diagnose inventories, track mitigation actions, etc., etc. So the main technique that we actually use to quantify emissions is Bayesian inversion. And here is like a schematic, but the main point here is that the inversion modeling depends on transport model. And so it is really, really important that we really understand how our transport models are working and that we quantify our modeling errors with that. So in that regard, I wanted to highlight this paper that we published in 2020, where we did some work simulations with many skins for a month in winter. And just to highlight a little bit of the findings of that paper and the open question that remained after that paper, for example, we found that MYN was actually the best representation of the PBL height for all hours. And that was all only done for winter. So the question remained is like, what else? So that's something that we are going to try to investigate, or that we are investigating, and I'm going to be showing some of those results. We also found that actually how the urban canopy models were implemented at the time, they were increasing biases in temperature and in PBL heights. So we consider that improvements on urban canopy models are needed, especially coupling with new modern PBL schemes, and also better input data. We also look at how the model was simulating the urban heat island. And we found something, and you can see it here. The urban heat island was peaking early in the evening. So you can see this part here of the figure. But we wonder, how realistic is it? How does it match with the observations? And also, we found a really interesting something that we expected, but it's like the PBL difference between urban and non-urban was increasing as the urban heat island was increasing, and you can see that in this figure here. So all these things, we have been continuing to investigate all these things. And for example, I'm going to show some results of the CoURAGE campaign with the Doppler lidar on the Twin Otter, and also for the DC Flags project. This all is all these measurements are managed by Sunil and Alan Brewer and their team. And we are using those measurements to compare numerical weather prediction models. We are comparing with state-of-the-art models, now Nature-RAD and ERA5, and also our own in-house WRF-RAD. So we were earlier looking at how that LiDAR and the heights. So you can, for example, see here one of the flights that it was actually in the DC area, Baltimore here, and this is the flight track of this. You can see the observations here for the wind speed and for the wind direction, and here you can see all the models, how they compare. This is a great data source because you can see we can see the spatial patterns and the vertical, and we can actually see how the models are performing. We are looking forward to many more of these. These are very useful. We've done the fall campaign for most of the flights were in New York, and you can see here some of their statistics. Takeaways is that wind speed biases for all the models are really similar, and for the wind direction, same thing. They are really similar and very low. So good for the models. Anyway, for Halo DC, we have wind speed, wind direction again. You can see here the measurement, you can see here the model, the difference. So we can put together, we also see vertical velocity variance with the LiDARs. They are very useful. We love them. We can compare the measurements with the model predictions, but that's for another story, for another day. Same long-term comparison of the measurement with the model for wind speed on top, wind direction. We see the same thing. Models are actually working pretty well. Very small biases in wind speed, very small biases in wind direction. A little bit of an issue on summer, not so big. Actually, if you can look at these numbers, it's actually below 1. A different story, a very different story is the boundary height. We've been looking into that also for the same period. You can see here WRF. NAMS, HRR, and ERA. The zero line, you can see the zero line here. So we see these two models actually overestimate, these two models actually underestimate. The numbers are small, so it's not like super big problem. But there is an issue with WRF in summer here. You can see an overestimation in summer. So why is that happening?
Israel,
Yes,
are those altitudes
those are different.
with meters per second?
No,
It does say meters per second.
oh, yeah, that's a leveling mistake. Apologies.
I'm not my ignorance of meteorology.
Just a clarification question. So is this ERA 5 or ERA 5 forcing WRF?
This is ERA 5.
ERA 5.
This is WRF forced by ERA 5.
Oh.
So, yeah. Yeah, apologies for the label. That's my bad. Anyway, I lost the train, so I'm gonna jump in the train again. Issues in summer. So we look at the soil moisture and of that WRF round in particular, and we also did a few other extra rounds with different configuration. I'm not going to go into detail, but I can explain later a little bit. The main thing is that the soil moisture here for the base case, that is the one that I've shown, is showing this thing here where it's drying a lot. When we do, this one is actually just initializing daily the soil moisture. It actually gets different, and the impacts on the PBL height are actually apparent. You can see here how we actually reduce the bias in summer by a lot in comparison. And also the medians are actually much better. The bad thing is we also decrease a little bit the performance during winter. But that is important. Soil moisture is important for the PBL heights. We look at surface skin temperature from GOSAR, only average for urban and non-urban areas. We use this for urban areas. The red is the urban area, and the non-urban area is defined in gray. And we've done that for all those cities. And you can see like the measurements in black, and the models are actually very different, especially in summer. This is like just 2 weeks period, but we've done this for the whole year. And this was, we were able to reduce this, to improve the performance by a lot by changing this parameterization, the thermal roughness length parameterization, and that was key. And that actually made the simulation be much better and reproduce much better, both in the urban area and in the non-urban area across the 4 urban areas. This is for the full year, so where I show that actually summer is where most of the impact is, and you can see that there. So we have average urban temperatures, average non-urban area temperature. So we can actually look at the skin at the surface heat island, and this is what the satellite is measuring. This is in UTC. So you see, like during the day afternoon is where you actually have the urban heat island. But the models, no matter what we do, we see this kind of urban heat island. So we believe that this needs to continue to be explored to really understand why is this happening, and can we get something more like this? So work in progress. Even though we have those differences in urban heat island, we see that modifying the parameters in the soil, either way this or this, did not make much of an impact. It actually changed the urban heat island here a little bit, as you can see, but there is not much of an impact in the PBL heights. Most of the improvement on the PBL heights were actually coming from the soil moisture for improvement. If you are running simulations below 1 kilometer, you have to take care of the glacier. We published a paper here. This is work by our postdoc Austin Hopp, where we did some runs for New York City and compared with aircraft. We were able to quantify the result versus the parameterized TKEs in the models at different resolutions and for different schemes. These 2 schemes are very new in WRF. Doppler LiDAR will help us very much because this was from aircraft. We only have like 3 flights, but continuous measurement of this has huge potential for helping us to better understand grades on issues. We flew downwind of buildings, downwind of Manhattan. You can see here TKA observing the plane. You can see here the same thing, but actually as a function of height. We see the TKA produced by the buildings in the measurement, but when we apply a model, we don't see that. We try many things. We changed the land use classification. We changed the parameters, the roughness level, many things. We were not able to improve it. This is not happening always. This happened, especially this day was a very shear dominated day and with a very strong wind speed. So maybe not like, you know, I'm trying to say this may be like a extreme case, but this was an issue that we observed. So we consider that maybe we need to start thinking on LES simulation that resolve the buildings directly. Or can we make our urban canopy models to be better so that we actually don't need to run this super high expensive LES simulations?
Is your what urban canopy model right using?
BEP.
BEP, yes.
Yeah, but here in this one, there is no urban canopy model. We did not apply an urban canopy model for this simulation. That is the one that I applied in the previous one. This is just a question for, can we actually, we don't think the current one without any modification will actually improve this because we already observed decreased performance in other parameters in the other paper. So
BEP is supposed to capture this building. I mean, that's what
it's supposed. Yeah, I understand that. So maybe the plain one will help us. I don't know. But anyway, so that is a potential route, is what I'm trying to say. However, BEP, at least at the stage where I last looked at it, it was only coupled to MYJ and BOLAC. But MYNN is much better than those two. So we need to at least couple them. And I think Jorge is gonna present some about that later. So I'm not really sure, but anyway, what are we gonna be doing? We also want to do large simulation, so you can put in that table. Actually, we are going to be focusing mostly, we are planning to do very high resolution for studying hyperlocal sources, modeling turbulence. We are going to most likely focus on the sea because this is our LiDAR here, but we may also do Baltimore because our towers are here. So you can see that we want to be doing, at least we are going to be doing LES, but we also want to contact groups with building resolving LES capabilities. If that's you, please talk to us. Talk to us because we want you. Recently, in some talks with Kevin Gurney from Northern Arizona University, he showed me some results of anthropogenic heat flux, or rather anthropogenic heat for a year. It's gonna be released really soon. Nominal scale is 1 kilometer resolution. This is anthropogenic heat due to the combustion of fossil fuel for 9 emission sectors, blah, blah. Talk to Kevin if you are interested. But the question I want to pose here, can we actually try to use this product, similar products, to ingest it in WRF, in the BEP, and make them better to fix that urban island issue that I found? Maybe that's probably just for us to discuss later, if we want to be doing that or not. And very excited about CoURAGE. Fantastic results. All this data is going to be great. For all the products we have, we will have measurements to try to prove the model. So we want to better understand turbulence in the urban area versus rural versus bay water. So very in line with the project. And again, as I said earlier, can we actually try to fix the patterns in the urban island? I'm sorry. And with that, I hope I did good in time.
Thank you very much. Been busy.
Yeah.
It's real. We did do a building resolving LES of downtown Baltimore, and I'm happy to share the output, the flow output with anyone who might need it. It's only the downtown area, so not, but you know, because we were doing multiple cities. But the paper is about to be accepted, and if anybody would have use for the flow field, we're happy to share them.
That'll be great. Yeah, and it would be, I mean, we would love to read the paper, talk to you more.
I'll share it.
Okay. Yeah, kind of new to the transport modeling thing, so I was curious, I think you basically said all this already, but the scanning aspect of the Doppler lidar, where it goes around and gets the horizontal wind speed and direction movements. That's the kind of information that you can maybe use to inform the transport models around the greenhouse gas emissions. Is that correct?
Right, I mean, the Doppler lidar will give you wind speed. Let me just show a figure here.
And the turbulence.
And the turbulence, yeah. You see the turbulence vertical stair. This is actually a cone, small cone, but because of how they need to measure the cycle, but it's actually almost like you can assume it's a vertical cone. And you see wind speed, wind direction, and turbulence. And there, this is very, very interesting. Actually, Sunil and team, they are working also in trying to develop additional turbulence parameters, but I'm not gonna talk about that yet. So anyway, so really interesting. And another thing is, WARF does not give you vertical velocity variance. You have to parameterize that, but anyway.
Maurice next.
So for your PBO bias plots, how did you make those? Like, the boundary height is like the truth is coming from.
I'm assuming that, yeah. I model minus measurement, and this is statistics. But I mean, every hour is measured is in there.
Those are not average by month.
No, this is not average. This is like a statistic plot of everything. The average will be the red, the median will be the black. This is the quantiles. This is the.
That's for each month, yes. That's for each month.
Yeah, every one of these is by month. Yeah.
Maximum boundary layer depth or afternoon average, what time of day?
Every hour.
Including nighttime.
Every hour, including nighttime, everything.
Right, okay, that's it. Yeah. It's integrated out a lot of ways.
With the thermal roughness line, did you increase or decrease it? And did you see an impact with that on the soil moisture, like the excessive drying?
Yeah, so that's a good question. Is with the thermal roughness length? With the thermal roughness length, we actually include a parameterization. It's not that increases or decreases, but actually make it dependent on the land use. So it's especially varying now. This parameterization is not a parameterization that I developed, but actually is already in work, but it's like hidden. You need to look a little bit and try to understand. So it's like actually not, this parameterization already exists. People have been looking into that. This parameterization was developed so that actually the GFS will work better for the skin temperature. That's why it's actually also working much better here. For the soil moisture, I didn't look into it.
Well, I'll chat with you.
Good. I just had to comment that we'll be getting those turbulence statistics over Baltimore in our flights in the coming weeks. So if that's helpful for setting up your LES or straining it, we get 3D winds.
That'll be great. And we also want the CO2 and methane measurements, if possible.
Yeah, we also get water fluxes, so we'll have latencies.
Cool.
Manhattan wide was like 200 meter above ground level. That was fascinating to see. The TKE measured at 200 meter above ground in Manhattan area.
Oh, that's Paul Shepson plane flying over the Hudson River. Where do I have that? So yeah, you see. So that is actually flying over here. And he will say that you could see the buildings very, very, I mean, they are right there. So those are also impressive measurements, but and very highly resolved in vertical, right? And the issue with that
It's
is,
basically getting the building scale, right, pretty much, because if it
well,
is
it's
on the
right
riverbed.
downwind of the building.
Okay.
You know, it's like,
It's on the riverbed, basically, right?
yeah,
Wow.
over the water. It's over the water.
Yeah,
Well,
yeah.
I'm not sure.
That's why I was surprised to see the altitude like 200 meters.
Yeah, this is over, yeah. And you
That
see
makes
here
sense now.
all the every 100 meters you have measurements. This is really cool.
Thank you.
Right, lots of good work, very thought provoking. We should move on to maybe one more presentation of interesting thought provoking work before we split for a lunch break. I think that's Maurice. We are behind schedule, but the discussion I think is good. You know, if we want to plan more, we should present less, but hearing what everybody's bringing to the table, I think is very, very helpful. There we go. All right, you're up.
Thank you. My name is Maurice Roots. I'm a PhD candidate at the University of Maryland, Baltimore County. This is my 5th year. I work in Balagimo's group, and customary to our group's research, I'm also studying nocturnal low-level jets. And I'm focused on how the mid-Atlantic jet and some of the mesoscale flows in the area affect the air quality, and particularly I am most interested in remote sensing observations from the ground. That's where most of my expertise lies, but I also use the existing routine network observations that we have in the area. And just pulling from the document that Ken provided, these are the 3 areas that I feel like I fit in and operate in. Of course, we have our own measurements at UMBC on our roof, the NPL net that's on a trailer beside the physics building, as well as some intensive operations with the Army Research Lab during this summer and potentially in the future. TollNet, Tropospheric Ozone LiDAR Network, as John Sullivan mentioned previously, are doing a lot of parallel work with them, and then also with the Unified Ceilometer Network with Ruben Delgado, and we have one of those ceilometers on our roof as well. So reading through the document, I kind of just like highlighted all the pieces that I felt like I would be interested in providing some answers to with analysis. Kind of a lot of them, because low-level jets was kind of just like all through the whole thing, which I mean, I was appreciative of that. It was kind of nice. So general questions, of course, in the full scope of things, the coastal low-level jet, but I'm really interested in, of course, how it affects the urban atmospheric environment, particularly in the composition of the ozone that's in the area and the pollutants like particulate matter that get mixed in from other sources in different areas in the region. What's new to me, but recently it's not that recent, but it's recent in terms of studying these kind of things. A paper was published by collaborators with us about cloud formation in Hampton, Virginia, about with a low-level jet that they found, and then not anything to my knowledge yet about convective storm initiation. So that's something really interesting. Of course, in our group studying SGP, a lot of the work has been done in how moisture transports and how the jet there in the Southern Great Plains is important for convective initiation. So that's really interesting to me. This is a figure from the paper that John mentioned before, but this is kind of like a blanket slide that I put together before I've seen this document before, that I think is really nice because it lines up with kind of the same things that we really need to have some more systematic observational based study about what's happening with these mesoscale flows, and particularly this regional coastal low-level jet here in Maryland. The kind of legacy story about this jet going back to William Ryan and a report that he wrote in 2004, which I believe when he was at UMD, right?
I think he was at Penn State, Bill.
Well, yeah, he was at Penn State. Yeah.
Just to make it clear. He was at Penn State for a long time.
Yeah. That's where he did his schooling, right? And then
Yeah, he was my grandson. Yeah.
yeah.
That's it.
And there were two reports that came out of those, but this was the most popular, and there was one that was right after this. But in that those 4 years, looking at those jets that they were able to capture from one site in Fort Meade, seeing that 44% of the exceedances that they were exceeding at the time of 85 parts per billion of the NACs were associated with a nocturnal low-level jet as well. So that's something really interesting that I'm looking to check up on, of course, because 85 is no longer the standard for the NACs. And the emissions have really cut down, especially as this is a regional flow thing with the other states in the area too. And then a piece that's kind of entwined into the document is that the formation theory for this one in particular is not completely decided as of yet. And so my work is in this area of trying to look at these from a more broad scope in terms of all the data that we have from the routine sites that MDE is operating. This is just more from the document that I think was really nicely put, and that I would like to help into facilitate the analysis for, especially the atmospheric composition. Being I'm really interested in ozone, and more recently into particulate matter because of the increased fire weather, and how that is impacting with or being affected by the impacts of the mesoscale flows that we're seeing. And this is where my work is going, into showing some of the morphology of this particular jet and teasing out the characteristics that really define what it is and what it isn't, as well as doing that climatology that I mentioned. And as I mentioned before about our group, everyone here except for Ryan and a lot of the low-level jet papers has been working with us and our group, and especially Will de Gabber, who did a nice study about low-level jets. It seems like a long time ago now, actually. Dr. Stroback has done some as well, which I think is around the same time is very useful modeling analysis on that kind of work. And then we mentioned about the Pandora spectrometer network. I don't think I heard anybody say anything about Aeronet either. But these are assets that I'm pretty involved in, because I also am on the NASA side too. And I think these are really helpful, especially since we have this corridor kind of lined up for us as where the transport is going, because as you know, the Appalachian Mountains moving right here and the jet following the curvature of the sloping terrain right here. This is like very primed to see how the things have transported in the transitional periods once things decay. Of course, we can't get nighttime measurements from these. I mean, theoretically you can, because they promise the lunar observations, but in standard data, you won't be able to. But in the transitional periods in the early morning, when things start to decay and the boundary layer starts to set up from the solar flux, it gets pretty interesting. For my work, I really like how you've set up this inline track observation, which extends with these networks here and into New York, where we also have some routine measurements from Tolnet as well, and then the cross track. Of course, Piney Run, Beltsville, and then Horn Point. That's where my analysis is focused on these wind profilers that are there. And I would very much like to use all the ancillary wind measurements that are being deployed, and that's I think a very interesting data set to get into. And then I'm gonna just end right back on here. My email is down here. Anything about UMBC or Tollnet or USCN, you can contact either Belai, John Sullivan, Ruben, or I about that kind of stuff. About data or analysis techniques, anything like that. Even toolboxes as well, because I write some of the code for that kind of stuff.
Thank you, Maurice.
Stop. Any questions? So the nocturnal LLJ that you were showing some of the examples, so is it like a relevance for like, is it more on the frontal synoptic situation or like on the more on the backdoor cold front? Because I'm seeing the southwesterly component here.
Yeah.
The measure. What is the synaptic environment, which is basically happens in this time?
So there hasn't been anything published on the full, what I would say, climatology about wind with those kind of systems, but if there is the wedge between two synoptic systems, I would say in my experience, you're probably going to see a low level jet setup. And so, yeah, there is association with that as well. And there's also another thing that I've been seeing, that there is something that looks like a jet coming from the north as well that I have not touched yet.
Yeah, those low level jets are pretty common even with the view highs.
Yeah, that
Yeah.
would be one of the setup that basically bring the southwesterly component, right?
Mm-hmm.
But typically in southern Great Plains, you get more on the cold front dominated, that you get a deep
Yeah.
LLJ. But in this area, it's different.
Mhm.
The air is not particularly dirty. So, terms of ozone.
Yeah, it's
But then the opposite.
say it again.
We can
What?
talk offline.
Wait, what did you say?
It's important, but it doesn't cause an ozone exceedance.
Okay.
Yeah, I wouldn't say it causes an ozone exceedance, but yeah.
Usually not.
Yes, yeah. Downwind.
Other questions? Online too. All right, thank you very much, Maurice.
Thank you.
Very helpful. Okay, we're about an hour behind schedule.
Yay.
It's not terrible because we have all afternoon at this point, it was all discussion. Next up, we had a series of Albany discussions, including Jorge, who is online. So I think we should ask Jorge Gonzalez Cruz, does he want to talk now and make us wait a little more for lunch? And then have him present when we get back? And then maybe hear.
Your screen,
Jorge?
that'll be
Oh yeah,
pretty
hang on,
fair.
Jorge, I can hear you, but I gotta turn you up.
Okay.
I gotta turn you up. There, you turned up, now we can hear you.
Can you guys hear me all right?
Yes.
Yeah, I can share screen if it's easier, all right? But I will need.
That
I will
probably
need-
is, that probably is easier. You should be able to, I will stop sharing.
Okay, thank you.
There you are, you got it. You're big on the wall now.
Okay. All right, so yeah, great to be here. Let's make sure can everybody see the full screen?
Yes, I'm gonna knock out that chat.
Good.
Yep.
Well, thank you very much, Ken, for organizing the meeting. My regards to everybody I have wished to be there, and I say that truly honest. I look forward to the campaign. So what we're gonna do is to share with the group what we have been doing in New York City and what we did for the Aroma campaign in terms of forecasting the weather and air quality for the domain, and see whether some of these tools can be used in our campaign, and whether that will add value to the campaign and even to test some models. And I'm going to skip this one in particular. I think it's probably well know that case. So, but I'm going to start with this busy slide to illustrate or to articulate what we have been doing over about 3 to 4 years now. And what we have done is to configure an urbanized version of WARP. I will go into some details of it. And we do this on a routine basis for New York City. And these results are sent out to some of our weather services, the Upton office in particular, and for research. And this is part of our commitment from our NOAA Search Center for a number of years. And this urbanized version of it goes to 3 or 4 days, all right? So it could be 72 hours, 84 hours. And we provide results on that time frame, and we do a forecast every day around, I think it's around 6 in the morning, and it's initialized with NAM. In doing the urbanization, we use the multi-layer approach, which takes into account the building topologies. And there was a talk just before launch about these possibilities. And some of you know Alberto Martile, who started those ideas with the BEP and evolved into the BEN, which is the building effect parameterization, the building energy modeling. And we have done some contributions into it. In essence, it fully couples the built environment mechanically and thermally, and also in the mass exchanges in the vapor content. That's a contribution that we added into it. So there was some discussion about heat flux, anthropogenic heat fluxes coming from the building. So this is in essence what the system does. Now, I'm going to go back to the previous slides, and you can see those Pluto New York City land cover data. This parameterization requires a lot of building detail information, building height, building plan ratio, and those are not commonly available. In the case of New York City, we have the opportunity to use what the city called Pluto, which is a tax lot building survey, and we have geo-referenced that and put it into our urbanized multi-layer parameterization. So in essence, every building is represented into our domain, which is, by the way, 1 kilometer is the highest resolution that we do this forecast, all right? Now, in top of this, we have done the partition between sensible and latent heat fluxes. And what we use is what I call a cooling light tower approach. So we came up with that idea a few years back, and we take all the energy that is coming from the building energy modeling and turn that into a heat flux, and we do a partition between sensible and latent, meaning that every commercial type of building, we assume there is a cooling tower. That is a major improvement over the dry case that was initially proposed in BEM. And that has proven to improve the forecast significantly, not only in New York City, but in other few locations that have adopted this approach. Also, the mechanical effects do take into account the building topologies, what we call using a variable drag coefficient that we developed jointly with Alberto a few years back. So the building mechanical effects are taken into account, and those are then brought into the momentum equations, and the turbulence equation as what we call turbulence production due to the building's effects. Additional parameterization that we have developed is to look at the surface changes in the buildings, if that will be the case, such as solar PV, for example, or green roof or white roof. So those are more simplified approaches that can be used. So those are options that we turn on for some research product. In addition is what we call the urban hydrology, is that is what happened during rainfall events. And in that case, we take into account what occurs in there. So the net result is that we have a quantification of the heat fluxes coming from the canyon and also the anthropogenic heat fluxes, latent and sensible heat fluxes all together in addition to the mechanical effect. So I'm going to go now briefly through how these outputs look like. All right, this is one example that Malush is going to give you a talk soon. A peak for illustration. So we can see that here, the evolution on that particular case of June 6 to 9, 2021, just a warm day. So the heat island is heavily, exposed here. We can see also the sea breeze driven flow, and we can also see the effects of the city in slowing down that sea breeze in the core area of the city. We can see my mouse here in this case. All right. So we do a real time model performance. So we gathered data from station that we have selected at the airport, JFK, LaGuardia, and also in Central Park, that's New York City. So as soon as we finish the forecast, as soon as the data is available, then of course, then we are able to assess that. We can see the performance is really, really impressive. In most cases, that's part of the evolution, that at least in temperature and in wind speed, pretty good as well. And we do that for a forecast that is a day from the forecast, a second day that's D0, D1, or D2, and that we can see how it degrades in about 72 hours ahead. Wind direction is challenging. We can see the wind shift, all right, that's the shift in the sea breeze. That's a little bit more challenging. We're still working and improving that aspect. In addition to this, because it's a fully coupled, all right, building environment and the urban environment, meaning the building energy exchanges are taken into account. It means that we've have to inherently forecast the energy consumption. That has a lot of value. In order for us to get the heat fluxes correctly, the energy consumption in the buildings needs to be estimated at the same time. So that's a nice byproduct that the forecast provides. Again, this is a second case. I'm not going to go into a lot of details. I think we got the picture how this forecast works. So for coverage, we think that this could be potentially useful in forecast mode. It's fairly efficient. At least we run it in our course. It takes about 6 hours, and we have dedicated that. So we release the course the rest of the day. We could probably initialize in IOPs twice a day if necessarily, and doing it on a short-term case. Now, the little challenge in doing this, again, is the case of what we do with the buildings, all right? So in the Baltimore, DC area, it has such a rich data set, such a New York City Pluto equivalent, like, well, that simplifies things. Now we have to go into use the other different techniques that are as effective, all right? They're, of course, they're not, resemble those are the WUDA case, where using local climate zones, we can represent the building reasonably well. And we have used that to extend our domain because Pluto is only available in the core of the 5 boroughs, and outside the surrounding area is not. And it seems that it gives us pretty good results. This configuration can also be extended, which we did for doing urbanized WRF-Chem, and we did that for the Aroma campaign 2023. It helped out to guide some of the on-the-ground campaigns, especially those on the mobiles, where to go exactly, where to chase the event. And I know some of the questions are about how the Baltimore DC environment impacts the regional environment and vice versa. So, but we may focus on some questions about air quality, heat waves. So I think that having the forecast will be very, very useful. The challenge again here is that the emissions in this particular case needs to be updated. So there was quite a bit of work by the CSL team and NOAA in doing that. Brian McDonald did that. But it did provide really nice, in the case of Aroma, because it was focused on air quality, it did provide really good guidance to the campaign. So this is one example for July 26, 27. We have a major ozone event, and these forecasts help out to support that aspect. And again, in the forecast, we can also ask questions about the anthropogenic heat fluxes. There was a lot of discussion about that. My colleague Pratar and I trying to get a proposal out to NSF in answering that particular question. So can we validate those fluxes, latent insensible heat fluxes from buildings? Can the models do that? Also questions about emissions from the building in terms of pollutants. So building air quality possibilities could be potentially updated. For this latest and on forward, actually, we have updated our model to use the 4.2 with NYNNN, and we just inaugurated that version a couple of weeks ago, thanks to Madhu that helped us to do that. And I think with that, Ken, I will stop here, and I'll be happy to have a conversations if there is time.
Thank you. Any questions for Jorge? Ellie.
Hi, Jorge. Good to see you even over the screen. Quick question. So, we were just talking actually about, coupling SLUCM with MYNN. So how difficult was coupling BEP-BEM to MYNN? And, how much of a hassle was that?
It took a PhD to do it, and we'll be happy to share the details on the codes. We had to go into all the turbulence equation, and Joe Olson was the key contributor to this. We're hopefully completing a manuscript with him on this aspect. We had the coding, but we had to go into the KE equations to document where the turbulence production will take place, so it can be dissipated all across. So I will think that evolving from where we are to your canopy parameterization, I don't think it's that hard from where we have it now. So we'll be happy to talk to you offline. I even share codes with you, Ellie.
Fantastic, thanks.
Yeah.
Darren.
So what's needed to do this for Baltimore? You mentioned you did this for New York with this blue tone. Do you have what you need for the Baltimore region?
Yeah, what we are offering is to contribute with this forecast configured for the Baltimore area. It will take us a couple of months to do it. And once it's up and running, it will be available to the campaign on a daily basis. And I think we can hold that in our servers to support the campaign. So what I'm proposing is to put together a actually small team, a forecasting team. I will not have the chance to stay in the discussions today in the afternoon, but hopefully we can put together a small group and decide whether weather and air quality or both is that what the campaign will benefit the most. And let's go ahead and do it. But I think we have the resources to do this and benefit from the campaign. We have our own interest to validate further in a different scenario, particularly in the case of precipitation, is something that we're just starting now. So I think the CoURAGE campaign will help us to push our urbanized weather models to look at precipitation more closer and with the observation that will be given.
I have a question for the team more generally.
Yeah.
Do you have a digital surface elevation map of Baltimore that has all the buildings? We have one that's very old, that's imperfect. Is there a new one? Is that the resource that everyone? Jorge, do you have one?
I do not. So my default approach is to go with WoodApp, all right? But if we do have one, that will be a lot better.
So WoodApp is available, and I have a DSM that I got through Claire Welty for Baltimore that I'll be happy to share with people. But it's pretty old and imperfect, but I mean, that might be a good resource if there's a newer data set for the rest of the team.
I guess that was the question I was asking.
Right.
Basic things, not good to see, but what
Yeah.
we need to get.
Yeah.
Make it more up to date.
Getting good land surface data is complicated. We need to
So
discuss.
that's a LiDAR data set that's giving you all the topography,
Yeah.
right, of every building and everything.
We need to discuss this. It's not a trivial job.
get good input data. I'm gonna go to Maurice. Then,
I don't know much about, but can people have something like that?
well, maybe we gotta talk about it, because it's not,
So the
it's
next-
not easy to get all this stuff
But
together.
the next best option, some people use OpenStreetMaps with something that gives you the footprint of the building, and then they estimate the height of the building in another way. That's kind of a way to generate this type of data if you don't have an actual LiDAR data set.
We do have 1 meter land cover from the Chesapeake Bay Consortium. What, you said no, Ben?
No.
Yes, we do. We have 1 meter land cover. I know that. I'm not sure about the digital elevation.
Yeah, I think we have tested the recent WUDA in comparing with Pluto, and it gives pretty good results. So that probably may be a first step to do, since it's a data that is readily available. And it does need some updates here and there in some of the properties, albedo, which we can get it from other sources like the eco stress and those unless we get a high resolution infrared later on. But I think that will be I would recommend a first step to start. And if we get a much better data set to share, and then we can actually test it again, whether it makes any difference or no. Perhaps a 1 kilometer would may be okay. If we push it for high resolution, we probably will need a much better high resolution, building heights and building plan ratio.
Ying.
Hi, George, good to see you. I have a urban canopy model question, is because the default model that we, for example, downloaded from the WOF website would not allow us to have our first, for example, model level to be below the building top. However, when we want to resolve the kind of turbulence scales, we also need to kind of refine our vertical grid spacing. I'm just wondering whether that's something your group have already updated, or something still really doesn't be done.
Yeah, so if I understand your question, great to hear you. So yeah, it's whether having the multi-layer, which has all the building, at least it consider building heights,
right?
Whether that impacts what's the effects within the canyon in terms of the vertical layers that we use. The answer is yes. So we do have to go very refined in the closer layer within the UBL. It's hard to tell exactly whether we're matching the building height. So let's say the canopy, the average canopy, or no, because it provides a range of results. So we just fix it at one given value, typically use around between 10 plus layers within the canyon before then we can expand it more uniformly. So it is a challenge, and we have done some sensitivities on this aspect. That say, one more additional variable that we need to pay attention is the building fraction. That makes a lot of impacts in the amount of building fraction. Typically, we assume 90% urban, and that really needs to be refined. So having a large, a high resolution land cover data set that corrects for that is important. Otherwise, we're just going to be overshooting the heat island. We just completed a paper on this, and we found that was a big problem there. So yeah, a lot of refinement within the UBL or within the canopy, and also refining the urban land classes is important.
All right. I'm going to propose that we need an ongoing discussion group about how to do these urban surfaces right. Because we've got a lot of different progress going in different labs, with different findings, but I think we're going to end up, it's kind of like the elephant. We each got a different piece. We should talk so that we can bring this together and get a complete picture. I think that's a good topic for this afternoon. Oh, wait, it is this afternoon. Okay, great. It's a good topic for once we break out.
Anting, I wish I could, be there and join you in the afternoon. I actually had to run to give another talk that was also late, but what I would suggest is we could, after the breakout, look forward, see the notes, or talk to my students about it, is to form a group to do this urban modeling, and we'll be glad to start coordinating as soon as we are able to do. I'll look forward to have many of you involved, please.
That sounds great.
Okay, bye.
Thank you, Jorge.
Take care.
Interesting at the BSEC level to also intersect with the other UIFLs to see what they are trying to do in terms of urban modeling. I know the Phoenix one, for example, has a good WRF level, not LES, but WRF level modeling. So yeah.
Great. Ellie, we'll talk.
Yeah. Thanks, Jorge.
There is a little bit along those lines in the works, but it's just showing up. Yeah. All right, next up, John Carlos. You got it.
I'm gonna have a timer to keep myself honest. So. All right, hello everybody. Good afternoon. I'm gonna talk today about some observations during Tracer on urban influences on thunderstorm precipitation. I'm really excited to use this as a conversation starter to see what we learned and what would translate to CoURAGE. So these are all of the people that have helped me do this really great work, and I'm just gonna click here and there we go. Okay, so this is something everybody in the room is very much familiar with after getting talks about this for at least 3 days. So what I'm really gonna focus on is what the story is for urban precipitation. So from one of my advisors, Bob Bornstein, the story so far, and generally speaking, has been very much centered since Metromex in the 60s about this downwind urban enhanced. Oh, yeah.
I forgot to share the screen.
Oh
no, wait, I am screen sharing.
It's sharing.
Yeah. Somebody can't see this. Sorry to interrupt.
Oh, all good. Yeah.
I see a directory of all the talks.
Oh, is it sharing the right thing?
We better share just
I got it.
folder. My bad. I'm sorry.
Should.
Yeah,
just share the whole screen.
I thought we were sharing the whole screen.
There we go. All right, can you see now?
Yes, thank you.
Great.
Sorry about that. Lost track there.
So yeah, the main story here in terms of urban precipitation and urban thunderstorm impacts is this kind of balance between the spectrum of urban modifications between thunderstorms initiated by a very strong heat island during typically calm or weak synoptic events or backgrounds, and then bifurcation at the other end. And I actually had, oh, whoops, gotta click on this again. Okay, there we go. So yeah, initiation versus bifurcation. So either you have a thermally dominated urban effect or you have a mechanically dominated urban effect. This was validated in a long series of papers just recently, 2024, for Beijing, which is an inland area. So the work that I've done for Tracer is kind of taking that into a coastal environment, seeing what changes. Also, it was done for very short-lived storms, about 2 to 4 hours. So seeing what that looks like over a variety of different convective events. So here's the study domain. This is all observational, not WRF. I just want to highlight that. These are all the observations that are needed in order to get these kinds of insights, mainly presenting using surface station and NextRad precipitation supplemented with rain gauge data. Here's the WUDAPT. The main reason why I included the WUDAPT here, even though it's an observational study, is that this tiny little series or section of skyscrapers does actually have a very strong impact on the dynamics, the urban dynamics for the area. So even though it might seem insignificant on a mesoscale, it can still play a large role in the urban morphology. So moving on. Gonna be showing snapshots from 3 different cases. So these are, this is one time with the surface temperature and winds, sea breeze front, and then the 1 hour accumulated precipitation for that hour. So what we see for a much longer lived sea breeze front thunderstorm, you'll see here the accumulated precipitation is 75 millimeters. So around 3 inches an hour is the maximum here. what we can see is that the sea breeze front actually severely bows inward over Houston. That's actually concurrent with the surface bifurcation of the sea breeze front flow. So essentially what you end up getting is that the sea breeze front comes into the city. The buildings are actually causing the flow to split. And that does that has an adverse effect on the sea breeze front progression. But then that also is seen in the thunderstorm, where the thunderstorm band has now split into two cells. That is also, this surface bifurcation is fed into the regional flow, which is northeasterly, and it causes this kind of also at the same time regional splitting of the precipitation around the city into these two bands that are kept pretty much on the north and south end of the city. So one other thing that's very interesting about this case to note is that despite the fact that you have the marine air and the precipitation, the city stays somewhat dry, but then also it stays pretty warm. So an hour after, we can see a very well-defined urban heat island of about 1 Kelvin, which is typical for daytime values, but in marine flow, I'm curious of what impact that has. So moving on oh yeah, this is 850 hectopascals. So moving on, here's our, I guess, a typical sea breeze front tracer day. You have a lot of isolated deep convection. So you can see again this presence of the sea breeze front bowing. Here you have the downwind reconvergence in the marine air that has cooled down a lot of the city and the area to the west. And then over the city, you can see that there's again this northeasterly flow that is basically enhancing the downwind convergence, and then also enhancing the precipitation in the downwind area. And then for an isolated squall, this is pre-sea breeze. The squall is ahead of the sea breeze front. What we see is actually the dominance of that, again, building barrier effect. There's almost no heat island during this time. So the previous, theory still does tend to hold up in terms of processes of what can we expect the urban thunderstorm interactions to look like. But also something that was new is that even though you have this thunderstorm outflow that wants to try to push into the city, it's actually kept outside of the city by a high pressure induced by the building barrier effect. And also something that was new that hasn't really been shown for Beijing or New York City, where the theory was developed, was that it actually kept the squall precipitation very clearly defined along the urban extent. So looking forward of how I think that this can contribute to CoURAGE, had to include a plan somewhere. So I think that we can really leverage a lot of Doppler radar. I think it hasn't really been used a lot in the literature or anywhere as far as I know. This is just a snapshot of the Doppler winds from the next rad. So some things that I've learned from this, and I can talk more with people who are interested in urban precipitation about why I included this, but what was learned was that there are many different urban thunderstorm modification patterns. A lot of them depended on different synoptic backgrounds. So I included that as like a one-liner in each of the slides. So there was a varying degree across different backgrounds, which is kind of counter to the typical story until now. Early interactions in all cases were due to the building barrier effect because of the diurnally low urban heat island. A lot of people here will know that afternoon heat islands tend to be pretty small. For Houston, it's almost zero because it's just the soil moisture is just not there. Also, a lot of the aerodynamic urban boundary layer responses from the building to the urban scale led to short-lived thermal enhancements where you get pockets of warm air either ahead of the sea breeze front in the Boeing region. Sometimes, again, in the first case, we saw that it ended up living behind the sea breeze front. One of the things we're theorizing that this is due to differential surface cooling from the urban heat storage and thermal properties. And what can we do looking forward? I've spoken with a few people here. I think there's a great, getting the urban surface fluxes and understanding how the evapotranspiration works in more detail and under longer term would be great. I had a few things here that I've learned is not as applicable with the C-band, but NextRad is still great. You can still get great results with it. Understand how these different flows in terms of sea breezes and thunderstorms look. And then also to quantify their impacts on clouds and precipitation. All right, thank you so much, everybody.
Yep.
Since the Chesapeake Bay is a little different than Houston, the fact that we have the Eastern Peninsula, do you think that will add some more interesting complication to this?
Yeah, so that's a great question. So this case actually, so this is a snapshot from the first case that I showed with the very severe bowing. It was a very weak, like weakly moving front. And what ended up happening was that that was where we saw the most severe frontal bowing. So I'm very curious to see where, you know, the bay is much more isolated than like Galveston Bay is just right out into the Gulf. I'm very curious to see. I think a lot could be done in terms of understanding both from observational and especially modeling, because, you know, that's why we started with the observations. I think it'd be really great to see how that looks. Yep.
Have done enough cases where you've been able to get composite?
That's gonna be my follow-up work for the summer. Yeah. Yeah. So we want to look at the long-term, understand how Houston, the mechanical effect on the sea breezes was really apparent, something that really stuck out to us. But I'm also very interested in like what dry versus like wet, you know, storm sea breezes look like. Mhm.
Thank you. Madhusuga? Come on up. 4 talks, then we can talk. But these are good. I think it's really good to hear what people are working on before we break up. And we have more time to plan and think. It's not just today. There you are. And let me go to show mode. All right, it's all yours.
Hi, good afternoon all. I am Madhusmita Swine. So I am going to talk on impacts of New York City over summer extreme precipitation. So this is the work done by the collaboration of Jean Carlos Pena and Professor Hure. So this is just a second. This is the outline of my presentation today, and the main 2 science questions I will be focusing on this presentation. First one is how the regional climate precipitations has been impacted by different urban parameters of New York City, and is our regional urban warp is able to forecast this precipitation are also the urban parameters or not. The motivation is, as all we know, the extreme precipitation is increasing nowadays, and it is also increasing over the city, New York City. And this increasing in precipitation is causing more floods over the region. And coming to the first figure, if you see from Gonzalez et al. Paper, if you see the precipitation is increasing, will increase also in future in next decade. And if you understand the urban impact over the precipitation, when the thunderstorm goes over the city, and due to the origination of more urban heat island, it just intensifies the thunderstorm over the city. So that the precipitation also increases due to this urban heat island effect. So then first we have studied the climatology of precipitation over this city. So for that we have used Mesonet data, which is present over the New York City, and this figure, it is the variation of anomaly of hourly precipitation over Manhattan Station, which is the station, the central part of the New York. And if you see, the positive anomaly is mostly present during noon time, which is around 12 to 2 p.m. We just ignore the nighttime precipitation because it is mainly due to the one day where there is around 500 to 600 mm rainfall on that day. So, and then to find out how many number of extreme precipitation days are present over this region. So first I have taken the threshold value, which is around more than 99 percentile of the precipitation, which is around 55.3 mm. So for in these 6 years, we are around 14 total extreme precipitation days. And out of these 49 events are associated with large scale low pressure systems over the city. So then from those events, we have selected 2 events. One is the intensification event, and another one is bifurcation event. So coming to the intensification event, this data it is from Nextstad hourly precipitation data. So if you see when the precipitation is coming over the city, it has been intensified, And the second case, when the precipitation is coming over the city, has been bifurcation, and it has been divided into two like extreme precipitation areas. Like one is on the northern side, another one is the southern side of the city. So on this day, we have checked the meteorological parameters like how temperature and wind speed and wind direction has been changes over this region. So if you see for the first case, for the both the cases, the precipitation has been occurred in the afternoon time, and during before to that the temperature it is more high over the city, and after that it has been like reduced as the normal case. And the wind speed and wind direction, if you see within this period, it is more chaotic, and it varies over the city. And then we just wanted to see how this precipitation has been changed over the time, like timely evaluation of the precipitation over the city. This is for the first case. This is around 12 p.m. local time and 1 p.m. and 2 p.m. How the precipitation has been changed over the city. And coming to the synoptic situations during this period, we have used HRR data, which is around 3 kilometer resolution. So this is the 2-meter temperature and the surface pressure and the wind speed at 10-meter wind speed. So it shows like the precipitation has been intensified over the city, but it was a large event, like large scale synoptic scale low pressure system. And there is a presence of large temperature gradient near the city, and the land surface it is more cooler compared to the seashore like during that period. Then coming to the second event, this is also the same as the first event, like how the precipitation has been evaluated during different time after 12 p.m., 1 p.m. and 2 p.m. Similarly, the HRR data synoptic situations, how it is varies the large scale features. Then we have simulated these two events with WRF, urban WRF data, like WRF model. This is the modified WRF 4.2, as Professor Hure has mentioned. It is the multi-layer urban canopy model with MINN PBL scheme. So we have just compared with two PBL schemes, which is the normal MYJ scheme, another one is with MINN modified one. If you see like the MIJ scheme, it gives the more warmer temperature over the city compared to the MINN scheme. And the wind speed, if you see, it is more giving small scale turbulences over the city, but it is not present in the MINN scheme. Similarly, for the second case also, which is the case which has been originated over the city and has been divided into two parts when has been crossed the city. Similarly, it is also giving the same result as the MYJ PBL scheme, gives more warmer land surface temperature compared to MINN scheme. Then we have like compared at the station point how the model is giving compared to the observation. This is the green color, it is the Mesonet data at Manhattan station, and this is the WRF 4.2 MIJ and MINN PBL scheme. From these two cases, if you see the both precipitation and temperature, it is giving better result of like MYJ PBL scheme compared to the MINN. So maybe now we are analyzing what is the causes of this giving the why MYJ scheme is giving better. But initially we have just done the like PBL height, how the PBL height is there during this event. So if you see the MYJ scheme, it is giving a good result as compared to MINN, because in the second case, if you see the precipitation has been divided into two parts when has been crossed the city. Similarly, the PBL height also it is giving the two parts of high PBL height in MYJ scheme, but it is not present in the MINN scheme. But still, we are doing the more analysis. What is the causes of this? Why the MYJ scheme is giving better in the model? Then this will be my possible contribution to the CoURAGE group. Like I can help to configure the urban WRF model for Baltimore or DC metro region, and also for the predicting this extreme precipitation, extreme heat wave conditions, and also validate this forecast outputs during the field campaign or after field campaign analysis things. So this, thank you. If you have any questions.
Something I thought of for both talks. Do we think aerosols from the cities might be playing any role on this type of convection as well, since the aerosols we think will have slightly different characteristics and or sizes than the rural or upland aerosol. Could that be having any influence if they're smaller and causing different types of cloud properties?
Yes, I think it will be there because I think I read one paper Harold has did like on the how the aerosols impact on not about the precipitation but how it is due to the urban heat island effect, how it is changes.
Yeah, I can also add to that. The aerosols is like an unavoidable part of the urbanization. The urban dynamics is like the main, I think, takeaways. The urban dynamics dominate the like you're gonna get the same storm organization and modifications. So then the aerosols basically affect the timing and then also the intensity, especially the rain of that you'll see with the precipitation.
I'm interested in what would be the spatial scale of the precipitation events that you have studied. Are they mostly like the localized, the like summer afternoon intense convection events, or are they like more or less part of the synoptic events or something else?
Okay, this is mostly during summer extreme precipitation that I have studied the two cases, and the first one it is a synoptic scale event, second one is like locally organized.
Another question? Yes, please.
Could you go back to the
Which one?
The boundary layer.
Um,
Sorry?
The red color. It goes up to 1880, I assume that's meters,
1800 meter.
and blue is 800.
Yes,
So it's about 1,000 meter difference.
in meter.
That looks quite extreme to me. Having seen lots of airborne LiDAR data,
Mhm.
I trust MYNN.
And it is at 1 p.m.
Yeah, no, having seen lots of airborne LiDAR data, MYNN looks more like what I see in the atmosphere.
You look at the clouds or. You look at.
No, okay, for this event? No, I have not looked. Okay, I looked at.
That was my comment. The variation in YJ is curious to me. I was wondering what the cloud.
Okay, I will check that.
Cool.
Okay.
Thank you.
Thank you.
Thank you very much.
I just.
Oh, that's all right. I got it.
Thank
No worry. Who's up next? Two to go? Audrey. And Audrey brings props. All right. It's all yours.
Thank you so much. So after precipitation, we're gonna jump on like back to air composition, air pollution. So my name is Audrey Goodell. I am a research scientist in Boulder, the University of Colorado in Boulder, and also at NOAA Chemical Sciences Laboratory. And so I'm going to talk about this project we call multi-scale quantification of air quality in New York City. But this project was really designed to add an environmental justice component to the big campaign called Aroma, or Aegis Plus as well, as different names, where they measure air composition in coastal urban areas. And so we focused on New York City, but we ended up having only one setup of a backpack. I will show it later. So it became a pilot project, and we used to evaluate models and satellite capacity to resolve air quality at street level. And so I start with these two maps of environmental justice tools. I don't know if you know about them. On the left is the CDC tool, and on the right is the EPA tool. And the reason why I start the conversation discussion with this is because you can see how high resolution we need information to get to the census tract information on how much between census tract you have and neighborhoods you have inequality or inequity in terms of environmental burden. So these two tools, they have different metrics for environmental and vulnerable demographic data. I'm going to focus on the environmental air pollution metrics, so for ozone and PM2.5. So for example, CDC will take into account the differences between the level and the national ambient air quality standards when the EPA tool will not. They rely on different time periods. So for CDC, 3 years, for EPA, it's 1 year, and it's to give the same index for 2022, but they rely on different things. The thing that is common is the data source. They use the EPA downscaler model, which is using EPA air quality system plus the CMAQ model. So it's 12-kilometer resolution. It's not at all designed to be resolving census tract or street level informations. And also we know in New York City, and this is even worse in Baltimore, the AQS network is very sparse. So they really heavily rely on model output. So it's in this context that we designed this project with this backpack. I brought it for you to see. So we walked across the street, across the city with this backpack. It's not that heavy. It has 3 instruments. So one is called the POPS. It has been developed at NOAA, CSL. It measures the size distribution of the aerosols. We also have a PAM from the 2B company based in Colorado that measure its personal air monitoring. So it measures PM2.5 mass concentration, but also NO2, CO, and it has relative humidity and temperature in it as well, in the box. And then we have the PAM that measure ozone. It's a research grade type of instruments, but miniaturized. So we really trust this data. And so the PAM is in the front, and then the 2 instruments, the other instruments are in the back, and they they link to 2 tubes above the head of the walker, so you don't have interferences from the walker. So hopefully the air we measure is really representative of what we breathe in the streets. And so we, at the time when we designed the project and where we wanted to explore or measure, we had the CDC map. The EPA wasn't out yet. And so the red rectangles are the regions where we wanted to sample to have like a large range of what they call environmental justice indexes. So these are the walks. We have up to 31 walks, but we actually can use 26 of them. So this is what it looks like. It's between 22nd of July and 16th of August, and the colors just correspond to the days. And we try to measure in different type of landscapes, so maybe representative of different type of source of emissions. So bridges, parks, streets, and then also along the Hudson River. This day to Jorge's point, that was 28th of July. And until that day, we were having our walks once in the morning for 2 hours and once in the afternoon for 2 hours. And Harold Gamero, who is in Jorge's team, who is a PhD candidate, told me the day before, don't go in the morning, start at noon and stay on the Hudson, like along the Hudson River for 5 hours. And 1 hour after his text, because he was in the committee preparing for the campaign to say to everybody, not only me, but all the aircraft measurement people and ground-based people, how it's going to look like. It's going to be a heat wave event. You're going to have a lot of ozone. So that's when you have to measure. And so that day we worked for 5 hours and we had the aircraft measuring in the boundary layer above the Hudson River. So that was a very cool, interesting day, and I'm going to show some results. So speaking of the results, these are the PM2.5 levels that we measure for each box. So on the y-axis is the PM2.5 level, and each box is 1 walk that we named, but it's very small. So it's the 26 walks for which we have both instruments measuring PM2.5. So on the top is the POP, so our reference, and then in the bottom is the PAM, so the plant tower that is also used in the Purple Air network and largely commonly used by communities. And so, as you can see, it's not that bad. Like the PAM quite compare well with the research grade instruments in terms of the variability between the walks, but it has differences in terms of the values, and I'm trying to show it in blue and green. So in blue is the POPs the shaded blue try to show the variability of the values, and then the blue lines is the average of each median for each walk. And then on the bottom, I put the PAM on top, and then, yeah, in green. So basically what we find is that the variability of the PAM is lower than the variability of the POPs. And then also the average of the median is lower for the PAM. So the PAM tend to underestimate, which is not exactly what we actually usually see with purple air network. We usually see the opposite, like the plant tower we see in urban area, at least higher values. So I'm still digging into this question. One thing that we saw, there was one day when it was pouring rain, and so we decided to measure in the subway platforms. And that's the day where we find one of the biggest variability of the numbers, and also the highest PM2.5 value compared to the outdoor measurements. And then for ozone, this is what it looks like. Ozone varied between 0 in streets where there are, sources of NO2, NO, and so there is titration, up to almost 90 ppb. The day where we had the highest median is the 28th of July that I mentioned, so the heat wave event. And so for the rest of the talk, I'm going to focus on 2 days, 2 case studies, one on the 27th of July, which is the day before the 28th, and it's also the second highest PM2.5 we measured, and then the 28th of July for ozone. So I wanted to show so 27th of July was a hot day with high PM2.5 and rather moderate ozone. It's not a heat wave event. It's not like a big, strong event in terms of meteorology, but it has high PM2.5. So on the left is the PM2.5, on the right is the ozone. These points are the actual walk. We call it the Williamsburg Bridge, which is here. So we measure South Manhattan and then West Brooklyn. And on top is the model, so the urban WRF-Chem model that we just talked about before. It's from Herald simulations. And so what we find for this day is that the model tends to underestimate the PM2.5 measurement from the backpack. And these are the POPs levels, not the PAM. And on the right, ozone is the opposite. We find very variability of ozone, strong variability of ozone, sometimes because we were indoor, so that's not the outdoor ozone, but still here, this is the bridge, and we have like a maximum of ozone on the other side of the bridge, close to Brooklyn. And so overall, the model tend to overestimate what we measured. And then we added purple air network here. It kind of corroborates our results that the model tends to underestimate what we measure. And for ozone, we didn't even have any surface data to test. And then for the 28th of July, so this is a very strong signal in terms of meteorology, like heat wave event, very stable, steady, air, very hot and polluted. And so it's along the Hudson River. Here you can see the points. And for that day, we also have the chance of having satellite images. So this is the surface PM2.5 retrieval from GOES ABI. It's a geostationary satellite, and that's something that's super important because it means that we can use tempo. That was the kind of a test bed to compare satellites with the backpack. And so on the left is the satellite, in the middle is the model on top of the backpack, and this is for PM2.5, and this is for ozone again. And so for that event, we found that PM2.5 is kind of low or moderate, and that's pretty well reproduced by the satellite in the model. And for ozone, pretty high. We find also kind of a like gradients of ozone along the walk. And so the model, which is the average of the 5 hours, but tend to overestimate someplace what we measured with the backpack. And we also add the purple air here. It kind of corroborates these numbers around 8-10 microgram per cubic meter. And for ozone, we have only one AQS that shows lower ozone than the model. and pretty close to what we were measuring at the same, close by, same region. Okay, that's my concluding slides, last slide. Back to the tool, the CDC tool for environmental justice. This is a graph from Kelly Colasino, who dig into the data that were behind the indexes. So that's the predicted PM2.5 from CDC between July and August 2016. They didn't have any for 2023. And so she was studying the distribution of PM2.5 across the 4 boroughs in New York. And so she shows that they're basically comparable, which is a little hard to believe, but that's because it's a coarse model. And the maximum values that they can find is lower than 20 microgram per cubic meter. And these are the backpack PM2.5 between July and August 2023. The distribution is different between the 3 boroughs. That was before we finished the Queens data analysis. So we don't have Queens, but and we also found like higher measurement. And this is like pretty, like we're not surprised because it's so much more resoluted that we can have these really extreme values of PM2.5. So take-home messages in New York City and Baltimore is the same, very sparse, HUS network. So we need more data, and we hope that the backpack can, bring this data that we need to capture gradients of air pollution. When we have strong event like heat wave, the different platforms, so satellite model and ground-based instruments and granular measurements agree, but when it's not that strong, then there are these discrepancies between the platforms. And so we really need a model development to reach the 1 kilometer spatial resolution that would really likely improve the environmental justice tools. And so the next steps, I told you we have aircraft data, and during CoURAGE Summer 2025, it's going to happen too, and we want to compare, especially for the 28th of July, what the aircraft are giving in terms of ozone NO2 and PM2.5, and we'd like to explore the CO and NO2 data from the PAM. We had like nice day where we compared with research grade instruments, but we didn't dig into the data yet. And then develop the backpack setup, having more backpacks to really answer environmental justice questions, so that having simultaneous measurements between, like in different neighborhoods, contrasted neighborhoods, and also upgrade the setup. So we will have an NO2 research grade instruments on board. We were talking about black carbon as well. That's a possibility to apply for Baltimore in the summer 2025. So the goal is to come back next year with more of those. So that's it. Thank you so much.
You mentioned the spatial resolution, about the vertical resolution.
Yes.
Because, I see the ozone titration there, for example, very obvious. And I wonder if there's a strong vertical gradient PM sometime.
Yes, there is. So Fred Moshari, who is based in New York, told me that he measured ozone with a drone, and he was showing like a peak at I think it's 50 inches. So there is a lot of questions about people who live like at the 4th or 5th floor of the building. And so, yeah, that's totally, and this is something we can do with the backpack too. Like we can ask if we have the capacity to go to.
Yeah, just walk up the fire escape.
Yeah, yes.
For the comparisons of the 2 aerosol measurements, I was wondering, A, is there a difference in the sizes that they might have upper and lower limits? And B, do you know what assumptions are being used to convert the count into mass concentration? And we can talk offline about some of those.
Yeah, I would love to talk offline. But yeah, the planet tower is a black box, as we know. Like, I don't know how it's also a sizer, but the conversion is, we don't know. And for the PUBs, we kind of play around with the density of the aerosols between 1 and 2. So here I showed the 2. The density is like 2 grams per microgram. But so for the range of the wavelength, the PUBs goes down to 140 nanometer, and I think the upper limit is pretty comparable. but the pups will capture more finer aerosols than the Trump Tower.
Yeah, I just for you, when suggested because all these monitors is the optical monitors. They are really sensitivity to the size of aerosol, especially you put the backpack for 30 to 50 members from New York. Normally, it's I suggest you also check the EPA DEC site. You check what their numbers. Normally, this number is unknown.
Yes. Good point. The only thing is that the EPA AQS are sometimes far, and we know that there are gradients, and they're also on the roof. So it can be different because of these vertical gradients. But yeah, I mean, so with Drew Gentner, based like from Yale and based in Harlem, we have this project to compare the background PM2.5 with the backpack, but we expect differences just because it's not the same location.
Thank you again. Let's move on. I was off. 2 more to go now. 2 more coffee then discussion. I propose. I think Sandeep is up next. There you are. There you go.
Thank you. All right, happy to be here. So basically the first acronym is a HEAT, and my student had to make a HEAT, so I was making the U-Hill. So urban heat experiment around Lubbock, Texas. So it is U-HEAT in a kind of a small city, small town study in a way to see the urban heat island urban advection. So Tyler Danzig made the main work, and also the students team, and also Oklahoma people with the modeling, and also NOAA team for the other part of the work. I acknowledge them, and also the NOAA funded project itself. So hot town somewhere in the city, that basically song 1966 hot hit song that basically comes to your mind when you talk about the Texas or hits or hot in the urban city itself. So why do you care? I think this population is not enough because you already know why do you care. Is going to go for that. Only one thing that I wanted to mention that Moscow, Paris, London, New York, Houston, Dallas. If you dig onto the urban heat island project, you basically see 95% are about those cities, or the people living in more than 1 million and all those. So smaller size cities actually did not have a much emphasis. So it actually make a big sense that the heat is a silent killer. That is a NOAA quote unquote on that. So it basically don't see a heat making a tree falling or something, but it's actually the highest amount of fatality in the United States. Like this is 2023. 2,207 people died in right now, like as of last month, the big heat wave going on in India that is also killing a lot of people during the election in India. So that is basically the heat is actually a biggest the fatality causing a weather event, and no matter what hurricane or tornado destroys building, $1 billion also happens. Fatality is pretty biggest on this point. So month of July 2023 was the hottest summer in the history of the United States or the globe around as well. And also the need to consider the impact of the urban plume. So we have all seen an OCAS 1960 paper, urban plume is going from the one side to the other. And that is the point. Only 3 studies have been taken into consider what happens to the plume. How do we actually define urban heat island? So it's basically a lot of trace back here. So I would like to bring the concept to this project and see where we go from there itself. So that's the, like I said, we don't have to talk about this slide itself because we already know about these communities are of that. Basically, that you can think about that in all the small size cities, all these hotspots, you can basically know which cities they are. So that is basically the point. Whenever you talk about your hometown, 100,000, 200,000 people, nobody cares about the heat in those small cities. That is exactly where you came from with the Lubbock as a test bed itself. And that is the population of the continental, with different continents here. You can see 82% in the North America lives in the urban region. And this is the map I created myself, that if you just extract the 1 million people out of the United States who are living in like Miami, Houston, or New York City, if you forget those 11 cities in the United States, that's the distribution looks like. Basically, the more population is living in this particular corridor, 100 to 300,000. So that is basically the 82% cities are actually smaller size cities in the United States. So that is basically the big big picture goal, we wanted to come up with that. And now get back to the plume. Like you have seen this picture multiple times since 1965 when the urban heat island plume was existed. So that is basically what to see if we actually consider urban region here and the rural region here, make the subtraction temperature minus a rural temperature simple. Everybody have been done, including me, right? So, but the point is that whatever the plume goes here, what happens to this place? If you consider this is the urban rural side, or that's the rural side, or that's the rural side, not that rural side. That is, the rural background needs to be decided and to basically compound the urban heat island effect. So you have to consider the plume itself to define, or I would call it redefine UHI at this point. So that is one of the ESA site measurements, and then in Lubbock Airport. So you can start off going to the airport is somewhere here. We have been seeing a much warmer temperature than the city itself. So basically now go back to the plume itself. Basically plume was going in the now southwesterly wind. And you might debate this is a desert region of the southwest United States, Lubbock, but it is still we have configured this study in multiple small size cities as well. So it's coming back. We'll see some results on that. It's a no-funded project. We have to go for the operations. We have to go for the National Weather Service readiness level. So we are at the readiness level 7 and 8. What does it mean? Basically, the concept needs to be brought to the weather forecasting model, and if the weather forecasting model can show the urban heat advection effect, then we can say we went to the level of 7 or 8. And these are the days when the temperature in the nighttime temperature goes like 80 degrees. That is a very high, low minimum nighttime temperature at the 80 degree at the outside. So that is in a nutshell about this project. Is basically improve observation of UHA in smaller size cities. We want to better understand the UHA, urban heat advection effects, and a guide better forecast to urban heat and within and around the city itself. So that's the West Texas Mesonet has 160 sites, but it's still a Mesonet covering 200 by 200 kilometer study. You can't really study the urban heat island itself. So then is basically we came to the 30 by 30 kilometer box set, and then we started deploying the instruments here. Also, stationary measurements, we also started collecting measurements with the van around the city. So then basically we see under different types of forecasted conditions whether we can make and sample the heat within a 2 hours, 3 hours time, because it's a small size city, but also going to the driving 40 miles per hour all around this takes a lot of time as well. So that's the network we have developed within this project, and that's this is one of the unique idea that we came up with, that we cannot, it is hard to actually get involved the community into the project science. So what we did actually, we let them involved directly so that the actual community's background is their experimental field. So we went out to the PSCHS, the people who would like to host our instrument, and the answer was yes. We had 100 people volunteered. We actually selected 25 because of sensor limitation and cost. So this is basically back here of the different houses. And then we actually started measuring that of the 2 meter height, grassy and all these things. And this is basically the heat map looks like a different day of the month, a time in the time of the day of the warm months. And that is basically, it's a month of February. And we're talking about 28 degrees centigrade. That was the February in Lubbock. 28 degrees centigrade temperature in the February daytime. That was the strongest, warmest, I think, the February in the history of Lubbock at that point. So what does it actually give this test bed? Basically, you can come up with the different months, 1 month, 2nd month, 3rd month in different August, September, October last year. And then you can start pulling out the nighttime temperature, because urban heat island is mainly the nighttime measurements, as you know the physics of it already. And then we can be basically the urban side and rural side. Now, what you see here that, we can define the urban heat island by subtracting this to that. The point is, these are the days when you have the identical temperature. That is basically synoptic events. You need to actually extract those days, and this is basically weather scale analysis come into play. And also need to consider the days when the wind is coming from the upwind or downwind or on so on. That is the concept we'd like to sell here on that. So there is basically one of the set of the days, urban side, suburban side, rural side, on the same night. You can see that urban heat island existed pretty much clearly on this. These are the different sites on the y-axis and different times in the nighttime, 1 a.m. to 4 a.m. You can clearly see urban heat island exist. But when you go for the other side of days, you can see there is no urban heat island itself, because the rural side is also warm, like urban side. Now that is basically heat is traveling to the same spot, and that we do not actually see the urban heat island to be developed. So that is basically the question comes: what is the urban heat island intensity? Is it 0? No. You have to consider the background of the upwind side to be mainly the background side to consider urban heat island. That was the basic idea here. So then we do all the calculation like this is the traditional background UHI, urban minus rural, and then you do with respect to wind direction. Then we see starting seeing the effect, because sometimes you can see negative urban heat islands in the night because your urban or rural site choice was wrong, pretty much. And then you start considering the upwind and downwind side, then you started to come up the results. And you can see these are the different days. On the northern side was considered under northerly wind, eastern side was considered easterly wind, and westerly side was considered westerly wind, and southerly side was considered southerly wind. That is basically background is changing on different days. Then you calculate the urban heat island, and then you calculate and you say the number, and you see the traditional urban heat island, this underestimate that compared to the when you actually do the wind sector segregation. That is basically the results here. So the negative urban heat island impact itself, because if you subtract the right number minus the traditional number, then you come up with a negative number. Basically, you can clearly see the impact of different days. So that is basically the major part. And sorry, the map is missing somehow. Anyway, so that was the southwesterly wind itself. So we actually started continuing the southwesterly flow 2 to 4 meters per second. That is basically see the urban heat island development, and it's the urban heat advection basically taking place on that. Unfortunately, this side of the sensor, we do not have enough sensor to study this part of the study, but would like to show the another case, northeasterly flow. You can clearly see under northeasterly flow, you can see that this part of the getting warmer. And we are actually considering this is the mainly background site for making the urban heat island intensity calculation. And then basically going for that, you started seeing this, the urban heat advection is taking place. And now we are quantifying the UHA in addition to UHII that has been traditionally done. So that is basically another condition that when you have a low on calm wind condition, neither UHI nor, the UHI is basically that you have a very built up 0.5 to 0.55 degrees centigrade, and then UHA is not taking place. So basically urban heat advection is negligible under this kind of low condition. There is a sweet wind speed between like 2 to 4 meters per second is the sweet wind speed Goldilocks, you can say. That was the basically sign we started seeing the advection. Now when the wind speed goes like 5 meters per second or 8 meters per second, everything becomes same temperature. So basically urban heat advection cannot be captured in that sense. So that is one of the summary results. We can see that urban heat island on the x-axis, urban heat advection on the y-axis, and that's your main cloud is sitting here. That is positive urban heat island is basically bringing the positive urban heat advection. Whenever the wind speed is appropriate, that you can clearly see between the 3 to 4 meters per second in the color bar here. So that is the sweet spot. The most of the results will be considered here. So there are some spots here. Now you can also see the wind speed is pretty strong on those days. So basically, you do not have impact of urban heat advection on those days with the higher wind speed. So that's the cloud would like to chase for, whether urban heat advection and urban heat island exist. So basically, the point is, if you have urban heat advection of the urban heat island, the advection matters most because this is the vulnerable population where they live, but they may not have the appropriate air condition to survive that heat in the nighttime. So that is why advection matters most as well. So these are the mobile part of the experiment. It is not only the Lubbock, there is a left side also. We have tested that the idea whether we move in a 3 to 4 hours time between like 1 a.m. to 4 a.m. Yes, we did not sleep for 26 nights in summer. So actually, out of that 1/3 nights, we did not sleep, and then we have to make measurements around all the smaller size cities. And this takes almost like 4 hours deployment with 2 vans. And that was exactly make measurements. Now there's one issue with we have to make a no precipitation, low wind or moderate wind, and also the cloudiness should be not present there. These are the constant we made the forecast, and that was the 26 days in summer we captured, and these are the different cities. Whether we can see the advection or not depends on the, with the mobile platform with the 2 vehicles moving around on the roof that I showed itself. That's, I don't know if it will work here. That's basically advertising that, oops. Oh no. It's okay, don't worry. This is the mesoscale activities, basically frontal passage. You can see the robustness of the chip aerosol chip sensors for that particular, basically the frontal passage was well observed. That's okay. Stuck. Okay, so that's basically the summary wise with respect to our ground-based measurements of small size cities. We would actually made the 22.5 census measurements in the small size city. 2 identical UAV mobile platform was deployed and was successful. We could quantify the most appropriate condition where the urban heat island advection would work. and also making the model data mismatch experiments using this platform. And also the new idea came from elsewhere that this urban heat also help human health effectiveness also matters. So that's pretty much it is. And I would like to also big thank to the other team members as well. Thank you very much. Yeah.
Great talk. I love that like summary figure. Two short questions. What's the relative like population size of it and of Lubbock?
Right. This is 265,000.
265,000.
Yeah.
Okay. And then also, I know it wasn't a part of your initial measurements, but do you have an idea of like the soil moisture difference? Like, is it much drier in that part of like, especially Northeast Texas?
Yeah, this is another part of the project. Soil moisture variability in arid region is like a pretty much ridiculous amount because we don't have that much variability in that if we have here. We have a very much like 0.1 to 0.2 that the volumetric soil moisture variability. Nighttime measurements is basically the major idea is the urban heat is actually taking place. But because we actually ignored the nights of precipitation, days of precipitation, because those are the days we would like to avoid because we want to see this energy balance without that in a way.
Yes. And kind of a follow-up question on soil moisture. I've seen indications that some cities like Phoenix that actually are wetter than the surroundings from people watering their lawns.
Right, that's a great point.
Negative.
That's a great point. We have actually, that's a great point. We have actually one sensor that is in the university, and inside the university campus, we have one sensor that we have to exclude that sensor because it has been nighttime gardening that had happened in place, because that's another project itself, sustainable gardening or something like that. So that we have to exclude that from the analysis. But if we really go for the soil moisture role, I would refer you to the 2003 heat waves paper in Paris. So basically the 30,000 people in Europe died not only for the heat wave, but also for the drier condition that exaggerated the impact of heat wave. So that is drier condition. Now we are dry anyway in the West Texas. That is exactly what we actually excluded the nights of precipitation. But that's a good follow-up thing. How much soil moisture impact the measured precipitation or UHI itself? Thank you.
So you're measuring urban heat island. Do you plan also to compare with the surface urban heat island? Or do you expect any?
That is we have another part of the project is that Oklahoma, they are doing one satellite measurements on the SUHI, SUHI. Yes, we're going. I do not bring the results here yet. But yes, we have surface measurements, the surface heat flux as well as model intercomparison. We did not bring that here yet. So
do you expect any differences in timing?
So the point is the surface in the if you really consider the traditional definition of the urban heat island, because it's vegetated versus the urbanized region. But in a Lubbock or arid region, we don't have a vegetation there that much. We are basically sand or naked, pretty much like land. So that is exactly, we don't know what will happen. We are still working on that particular satellite programs. Thank you.
Okay. Good, thank you. When to go? No one? Oh, wait. And now for something totally different.
Totally different, yes. In every aspect different. And it'll be really short. I have about 3 slides, so you're very close to your colleague. So I'm going to talk about there's no results. It's just the thought that I had when Ken just came applauding me. Hey, Sharon, you should do something. So then I think, okay, I should do something. And I also made the same observation that Bernard was talking about this morning, except I only have a hunch. He's got the resolution of grass blade. I have the thinking that, the summer is really busy. Everybody's bringing their instruments. You're in research mode, and everybody's there. Usually for that many field campaigns that I've been through, the winter is a quiet time. So what can we do, to add some scientific value with the existing observations? Especially with ARM, they have something sitting on the ground like year long. It's the same data quality. And I'm thinking it could potentially spanning 2 seasons because we started December 1st, right? If we have some good results coming out, we might push another month out of their.
I don't know about that.
We'll talk about it, but yeah, this is just the thought.
Suppose you could ask.
Again, yes. So, essentially what I think, I mean, again, it's just me thinking, I welcome any suggestions. I know it's probably a bit deviation from everybody. So what I lived here long enough, I noticed that usually when the winter precipitation comes along and there is a separation along the I-95, so to the east of it, it's usually liquid phase, and to the west of it, you've got nasty stuff going on. And then I-95 normally gets pretty bad, complicated situation. So this I dug around and then I can't exactly find any data with the mixed. There's how you define mixed phase precipitation. So what I have is just the freezing rain. So the stuff that's coming down, they melt and then they refreeze and then they hit the ground. And then depending on the ground surface temperature, it could be ice, it could be just water. It'll make a huge difference in my morning commute. So that is some data that from 2003 by Chanu, and he did 988 stations between 48 2000. So this is the freezing rain day over that time. So you can see there the sharp gradient along the East Coast and where the 95 goes up there. And there are a whole bunch of factors that I put it together. A lot of them are actually very relevant of what we're doing, especially some of the smaller scale things. So it might be interesting to put those things together, and then it'll be a very interesting modeling study, I'm sure. So ever since I thought about that, I started to pull some of the phase separation off of the weather forecast. So this is just 2 events when I started to think about it in December. So those are 2 cases. I probably get 4 different cases depending on if I'm alert enough to actually go there and then take the screenshot of the forecast every 3 minutes. So on that side, on this side is the actual radar retrieval. So what they gave out to the current situation, where the pink one is the mixed phase, the blue one is snow, and then the normal color is liquid. So those are 2 different days, January 1st and the 6th. And this part is a part of a nowcast. I took those off from a WeatherBug. So different people do different nowcasts. I try to contact them and trying to see like how they did it. I didn't get my answer, but I suspect what they do is to look at the WRF output of the air temperature. So when they do nowcast, maybe I think it's about 1 hour, 2 hour ahead. Usually you get this type of nowcast. So there is a line, maybe it should be the temperature, but don't hold me accountable for that. I'm just guessing. So they will predict all mixed phase here, but in reality, you have this dome that's bent over and they have more water, may or not be related to the urban effect. Pretty much the same thing goes here. And I roughly, again, don't hold me accountable. I roughly put 3 of those locations over there. So if we have some measurement at 3 different locations, and with them, we'll be able to understand a lot of the local conditions, and with the same system, how the surface precipitation partitioning and how that goes with the time. That's it. Okay, so any thoughts? And I mean, I don't know much about that, not much more than you do. So I would welcome any thoughts, and thank you.
I guess just from a modeling perspective, what I would be interested in seeing in this kind of work is you show this very distinct line there. It said that the vertical structure of the front our actions will be important to what kind of precipitation you get. You know, whether or not you get a cold front that's conducting or a warm front that's conducting, that change in the vertical structure temperatures and the optical width, it's just that the precipitation is going to be into the age.
Yeah.
That's those kinds of tools, those kind of cross-sectional capabilities, slice it, dice it.
Yeah, it'll be easier for us to get synoptic conditions, like when this type of system comes in. I think that should be easy to get the synoptic scale. The biggest thing is the topography and Appalachian mountain that goes along the area. And then sometimes you get blocking flow. And then that is probably the main reason. I don't know. But I just want to know, see if are there any local effect? Maybe not. It's worth an hypothesis and check it out and see if the model can actually do it. If they can do it, that'll be an improvement of forecasting skill too.
I just know that was a huge challenge for us in operation.
Yes.
Like we run up and down stairs talking to people.
Yeah.
Why this is
Yeah, and then your forecasting come out, my kids will have to decide if they'll close the score today. And a lot of times it comes all rain and then I get people complaining, hey, what is it? We've got rain, we are closing the school for 3 hours. It's very difficult, yes.
Carlos. I'm super interested in winter urban precipitation. Immediate thoughts, things that I looked at from Houston that translate and will be for CoURAGE. The vertically pointing hot end might be interesting because with summer convection, you know, it's very localized. So if it doesn't pass over it, then you won't see it. But with something that's more synoptic, you might be able to see the structure, microphysical properties, and that might help inform a little bit more. Also very interested, I don't think anybody's really looked into it. Again, winter urban precipitation is really like the blade of grass. And one thing is the impact of the heat island on affecting the melting layer. Yeah, where it is.
Yeah.
Quick comment, MDOT, right, that's great stuff. Maryland Department of Transportation, they hate that snow line that runs right through the middle of Maryland. And anything that you can do to improve where the snow is gonna fall, they will be interested.
Yeah, I think it comes down to it's gonna be difficult handling for the modeling. And if we could get something, the detail in the city, play into the, you know, and get detailed forecasting, that'll be nice, yeah.
It would be a customer.
Yeah, okay, yeah, hopefully I'll get enough interest and then we'll be able to, here's the boss. I mean, he'll have to say if we can pull off this or not, so.
I'm not the boss of any fund.
But at least for this year, we've got to.
And then public transport spot seems it's all around 695 and 995 for this. They were out with according to MDOT's belief.
Okay, if you guys can help me sell the idea to MDOT, I really appreciate that too.
All right, thank you, Joanne.
Thank you.
All right, we're almost on time. That's a bad joke. We're not close to on time, but I thought, you know, this is good to learn what everybody's up to. Now we have time for discussion. Thoughts? As suggested, maybe we should grab some coffee before we head to discussion rooms. I had said, how about surface atmosphere interactions in one group, atmospheric composition in another group, and maybe clouds, radiation, and precip in another group. I think we have a lot to talk about the physical modeling of the city. I think that surface atmosphere interaction topic is pretty hot. My sense is also that all the atmospheric composition mobile resources should be doing some talking about how to coordinate, maybe.
Yeah, we'll find each other.
You don't need to?
flashing.
You're fighting.
Who's the
Yeah, that's
best.
not any good.
So
that's a joke.
3-lane highway.
We're gonna have a demolition derby. See if we can destroy.
Drag racing.
20 miles an hour down.
All right.
Yeah, it would be good for all mobile measurement, people get together for composition. Yeah.